Okay, we are good to go.
Thank you, Mano. So, welcome everyone. My name is Sotiris. I'm a professor at the Tech University of Crete, and of
So Tiris, you are breaking up, at least for me.
SAPPAN, CyberSANE, and a number of other projects that actually welcome you to this event again. It seems that quite, but also some. I think we have some noise in the way. Some noise in the line. Anyway. Attending. The topic of the workshop is in the domain of countering cyber attack and response. This is quite an important problem. I'm glad to see that a lot of the European projects actually, as I said, and also activities in Europe have been focusing a lot more on setting up SOCs, security operations centers, that are designed to have a systematic way of countering these sorts of attacks that have been cropping up. And we're actually quite lucky to have with us Ioannis Sarafiotis from ENISA that is going to give a keynote talk about security operations centers.
So Teris, I think you were breaking up a little bit.
Okay, since Sotiris...
Mano, can I go ahead with the presentation?
Yeah, please go ahead, Ioannis.
Thank you very much. Let me just share my screen. Please let me know when you'll be able to see the presentation.
Yes, we can see it now, but it's not in full.
Excellent. Well, thank you very much for inviting me. So my name is Ioannis Sarafiotis. I currently work for ENISA, and it's a real pleasure to be here on an academic workshop. It's rather refreshing for me. I have an academic background. I've been working for the University of Oxford for at least 10 years as a senior researcher, and I was also teaching and lecturing there. So it is really refreshing to be back in a more academic background and see how Horizon 2020 projects help push the boundaries of knowledge in cybersecurity. So today, on behalf of ENISA, I'm here to give you a presentation on two different projects. Hence the little bit, yes?
We don't see your presentation in full mode, and also the slides are not changing at the moment.
Really? It is on full mode in my screen.
I can see it in full mode. By the way, my line dropped, so I'm not sure what the last sentence was, so apologies for this.
No worries. I can see it in full mode as well, Manos. I'm not sure.
Okay, let's go on. It's my problem, probably.
Okay, perfect. So I was saying that I'm trying to merge two projects that we did last year at ENISA, and I think are of value to the Horizon 2020 projects, and probably will shed some light into opportunities for further work in cybersecurity. Hence the weird title, from cybersecurity operations centers to securing machine learning. So as you know, a couple of years ago, ENISA started working in the area of artificial intelligence. The way that ENISA actually does work in areas that are emerging in technologies, we try to gather a group of experts, and we call them ad hoc working groups, and with the help of these experts that come from different backgrounds and from different member states, we design different projects, and we produce at the end of every year a report on a pertinent topic. So 2 years ago, we decided to do a project about the artificial intelligence threat landscape with the help of experts. We identified different needs and assets that need to be protected.
Sorry.
Yes?
Sorry to stop you again, but I received multiple messages that we cannot see it in full mode, and your slides are not changing. So if you could restart.
Okay. So they changed that. Okay, I could do it again. I could stop sharing and start again, maybe.
Okay, thank you very much. Sorry for
Yeah, sorry for this. And thank you, Mons. And I cannot see the messages when I'm sharing the screen. So thank you for
don't
letting me
worry,
know.
we will keep track of that.
Perfect. Okay. Any better now?
Again, we don't see the full screen. We see the, the PowerPoint view. I don't know if you have two monitors. Maybe you could switch.
No, I have only one monitor. I have only one monitor, and I see the full screen here.
Oh, okay. So no
It's very
problem.
strange.
Just click on the slides on your navigation on the left.
Yes.
So we can do the next slide. Let's.
Do you see the next slide now?
No. Could you click
No?
no, leave the full mode and just click one slide to the next, so we can
Yeah,
see.
that's what I did. Can you see the next slide now?
No.
Or no?
Do you want to mail the presentation to me so I can share it for you? Now it's changing.
Okay, but now I have exited full mode.
Yeah, okay.
You should check the slideshow menu.
Mana can send it to you if that it is easier. Or I could do it without full mode, and
yeah, I
if you
think
can see the slides changing.
We can proceed without full mode if you also can.
Okay.
The toolbar.
Yeah, I don't mind at all. Do you see the slides changing now?
Yes.
Okay, perfect. Let's proceed like this then without full mode. So I was saying that we did a report 2 years ago about the artificial intelligence threat landscape with the help of experts. We started with identifying the different assets in AI. Then we proceeded with the different threats that organizations should identify in their environment. And we provided a report, a detailed report. It was the first time that NISA did something like this. Last year, we decided to do something slightly different and focus on a little bit more narrow area, this of machine learning. And we thought that there are three different lenses that someone could actually perceive machine learning in cybersecurity. The first one, which is the most usually explored, is when you are using machine learning to detect different types of attacks and threats. And this is something that many projects have already done so. The second one is when someone is using machine learning to create different attacks. And the third one is something that it is usually neglected, is how machine learning functionalities in different systems can provide new threat landscapes and new attack surfaces. And this is something that we didn't see in the literature much work, and we decided to create a taxonomy of how different attacks manifest in machine learning environments. So what we did, we started with a desk research, and we did a systematic review of all the different machine learning algorithms that exist out there. We reviewed more than 150 different peer-reviewed articles and white paper reports from well-esteemed journals, and we tried to create a taxonomy of the functionality of different machine learning algorithms. The second step was then to validate this taxonomy with experts from our ad hoc working group and experts of the machine learning community out there before we proceeded to the next step, that was the creation of an attack taxonomy. So again, we went back to the literature. We identified different types of attack that targeted specifically machine learning algorithms, and then we tried to also identify different controls that this paper suggested that they should be put forward to protect our systems and deter and mitigate these attacks. And at the end, we tried to do a small exercise where we consider different standards that exist out there, such as ISO, for example, and NIST cybersecurity framework, in order to identify whether these controls were sufficient for the attacks that we have identified, or whether we need more targeted and novel controls for machine learning. So what we did, For the taxonomy, we consider different of machine learning algorithms. We consider different criteria. For example, the types of data that the algorithm is consuming, the way that the data is being processed, any kind of data environment that the model lives into, the learning paradigm of the different machine learning algorithms, and also the business application. So the usual suspects we consider in terms of different machine learning algorithms. We consider models that they do some more quantitative analysis and are used for prediction. We consider algorithms that are used for NLP, natural language processing, or speech treatment, and also algorithms that are considered for computer vision. We also consider different learning paradigms. Again, no so big surprises there. The supervised learning algorithms, unsupervised learning, reinforcement learning, and semi-supervised also learning algorithms. And we also focused on two extra functionalities. The first that we think they are fairly important and need to be acknowledged. The first one was explainability of the algorithm. So whether someone is able to explain the way that the algorithm is functioning to a human being, and this is very good for transparency. And the other one was the confidence intervals, and this was another way in order to identify a little bit more and highlight a little bit more the explainability of the algorithms. And by confidence levels, we mean usually there are algorithms out there that provide a confidence interval, saying that we have an estimate that this image, for example, resembles a dog with 95% certainty, but the confidence level on top of that is how accurate the model we think it is, and it could be up to 55% in this example, for example, that you see here with the cat. And this is something that could add on top of security measures that we have in order to detect potential perturbation attacks in machine learning. So this is the taxonomy of the ML functionality that we came up with. You see different domains there on the left, the different types of algorithms, the learning paradigms, and then of course throughout you see all the usual suspects of algorithms out there, from neural networks all the way to hidden Markov chains, for example. And we have published this report in December, so it is available online for you to have a look. What it is more important is that we identified different types of attack in the literature. Again, we didn't find any big surprises out there. These were pretty much well-known attacks. For example, evasion, when an attacker is trying to take advantage of small perturbations in order to mislead an algorithm's output. There was the type of oracle attack, data poisoning, and also some other more mainstream attacks such as ML failure or malfunction, the disclosure of different data, and compromise of other applications that are related to the ML. Once we had our list of attacks, then we try to consider what types of control we need to have in place in order to deter and mitigate these attacks. And we consider, first of all, as we said, some standard protocols that organizations use, for example, ISO 27001 or the NIST framework. And we realized that in the majority of the attacks, these frameworks were not sufficient to either deter an attack or mitigate the impact of such an attack. And then we relied again on the literature to identify what additional novel security controls we need to have in place. For example, one such control was to train the machine learning algorithms with data that will deter the different perturbations, and or to identify when someone is trying to exfiltrate data from your system and try to have an RBAC model, for example, in place to see whether they have access to this or not. So we identified all the different spectrums of security controls that we need to have in place, also the novel ones. And then what we try to do on top of that is to link the attacks that we have identified to the vulnerabilities that are exploited by these attacks. And also we try to associate to these vulnerabilities certain security controls that we think that are important. We finished the report and we left it this linkage in a very abstract level, so we don't really provide a lot of information for every security control on how you could actually try and go and implement this security control. This is fairly pertinent, we think, especially for the more novel controls that we identified for the machine learning algorithms. And what was very interesting as well was the fact that you may have a situation where you may impose one control on machine learning algorithms in order to improve the security of the machine learning system in total, but at the same time, you may be reducing the functionality of the same machine learning system. So, for example, if you try to add adversarial examples in the data set in order to deter any type of adversarial machine learning attacks, then at the same point you may be reducing the confidence intervals in your machine learning system. So this is a very delicate subject, and we think that more research should be done in order to identify when we need to apply the security controls, how we need to apply the security controls, and when we have to make a very hard decision between reducing the security or reducing the functionality of the machine learning, how do we make this decision? And this is an ongoing work for us, and this year we will focus exactly on this. We will try to provide through 5 different use cases detailed guidance on these novel security controls, and also some guidance on how you try to make these difficult decisions. And we think that it is an area that it is usually neglected in the literature, and the security controls for machine learning is an area that definitely more projects could actually focus on, and we will benefit from this in Europe. Now, the next project that I would like to talk to is about the security operations centers. Sotiris mentioned before that ENISA did some work, and we also had Sotiris as an expert and his team to help us with this initial report. There was a request by DigiConnect to provide some guidance and recommendations on what EU activities we need to have in the area of security operations centers in order to increase and enhance the maturity of SOCs in EU. As you know, there is a European strategy in cybersecurity that envisages what they have labeled as cyber shields, which is basically a network of SOCs. And we are far from have a network of SOCs in Europe, and the idea of this project was to identify what are the requirements that the member states see as critical in order to either build more SOCs or enhance the functionality of SOCs, and most of all, how we can actually make them talk to each other. So what we did, we first started with a desktop research. We tried to identify what is a SOC, what services they offer, the range of tools that these services utilize, the type of roles that these SOCs have for the human analysts in place, and then we try to identify from the different types of SOCs which are the most critical for Europe. So we have identified that there exist several different types of SOCs, private and in-house, MSSPs. There are also hybrid forms of SOCs, some that actually have partially in-house capabilities and they combine them with outsourced capabilities. There are public SOCs, sectorial SOCs, there are national CSEDs, so there's an abundance of different types of SOCs out there that they have also different roles and different functionalities. We also identified from the review that there is a large number of MSSPs per member state, and it's like a fairly segmented market when it comes to the different tools that the SOCs are using and the different methodologies and the different providers that they offer these tools and services. We also identified the difficulties in working internationally, and that most of the cases when cyber threat intelligence is taking place in member states, the national CSERT acts as a hub. And there are very scarce efforts when it comes to private companies joining either CTI associations and communities or participating in the national CSERT. And we hope that this is going to change with the NIS Directive 2, but it is something that we should also focus a little bit more. So once we had the desktop research We try to do interviews, surveys, and focus groups with different experts in the field. We did a survey with, we actually sent a survey to all 27 member states, and we requested specific information about the public infrastructure on SOCs. We got replies from 15 different member states. We also did, on top of that, some interviews in order to get an insight of the private sector capabilities, and we engage in interviews with experts that work in private SOCs, with people who work in CTI associations, and also with people that have participated in Horizon 2020 related projects. And we proceeded further on with focus groups, which we recently finished like a couple of weeks ago. And these focus groups, again, we focused on acquiring more details on 4 main different themes that we identified from the survey and the interview analysis. So these 4 themes or pillars, as we name them, that we need to focus targeted interventions are governance, data sharing, tools and organization, and incentives. And in order to help us this year with the work that we will continue to do, we formed an ad hoc working group, and I think many of you are members of this ad hoc working group. We've got a very strong interest from the SOC community. At the moment, we have more than 45 different members in the ad hoc working group from diverse backgrounds and from different member states. So some preliminary insights to our research. We identified that for the governance, it is very, very important to come up with a maturity model for SOCs. At the moment, there are not that many maturity models out there. There is one that is extremely good from a researcher from the Netherlands that it is used. It is open source and freely available for every SOCs. When it comes to identify SOCs that can actually enter a network, we thought that it is better to come up with a more lightweight version of this model and emphasize on key points that are of interest for the sharing of data. So one area that we're going to actually start looking is to create another version of this maturity model for SOCs, that it is openly available for everyone, targeted for a network of SOCs. We also see that there is a need for playbooks and in particular how you actually are able to share different playbooks, and this is another area that we're actually going to look into. When it comes to infrastructure, we identified that several member states will proceed with their public SOCs and they will create what they call federated governmental SOCs. At the moment, most member states, they have siloed SOCs that cater different types of the public administration. What they want to do now is they want to actually create a federated SOC that will get input and feedback from all these different siloed SOC communities, and it's an effort that we would like to support further. There is also a need for joint SOCs, and this means that different countries are going to be able to monitor, detect attacks on their networks and share information much easier. We also identified that there is a huge need for sectorial SOCs or sectorial certs, where they will be able to tailor information for a specific environment and the functionalities that this environment may have, and this will provide extra information and intelligence on cyber threat data that are shared. And that we have many difficulties in CTI exchange because of the current policy and legislative environment. So people identified problems in sharing data when it comes, for example, to GDPR. They said that sometimes they thought that they were in a gray area when they were sharing this information, or when they were receiving information from another partner, they were not able to identify whether they should share this information further or not. When it comes to technology needs, emerging technologies such as machine learning, for example, it is currently used in SOCs, but with a little bit of let's say fear, as many SOC analysts reported that these technologies cannot be trusted due to the high number of false positives that they provide, and they think that it is worth researching further such tools and capabilities, because they can really contribute to the detection of the attacks, but at the same time we need to make them scale in a real environment. We also got information that it is worth exploring in designing tools that will help automate different processes that SOCs have at the moment, and they are most of the times these processes are taking place manually, and it is rather time consuming for the analysts. And of course, the last pillar is awareness and education needs. We identified that there is a huge need for training for the SOC analysts. We need to actually help the SOC analysts evolve. We need to make their work that they have less mundane, in order to be able to attract more SOC analysts that are needed. And of course, we need to design awareness campaigns in order to attract more SMEs and non-critical infrastructure companies that can join CTI and enhance the community further. So these are the main primary insights that we have identified, and what we are going to do from now on for this year, for this project, we, with the help of the ad hoc working group, we will create 3 different task forces. The first one is going to focus on creating a maturity model for CTI sharing for SOCs. The second one is going to focus on playbooks sharing framework, and the third one is going to try to create a taxonomy for cyber threat intelligence. This is another area that we think that there is there are quite a lot of taxonomies out there, but we just need to consolidate them and try to have a common taxonomy that all the different SOCs will be able to use. They are, at the moment, they are using the majority are using the MISP platform, and all the functionality is that this platform offers. There are several taxonomies that are defined in the MISP platform, but what we have been told, there isn't a baseline of information that will be shared in specific incidents defined. And this is a huge problem because it affects also the quality of the information that you receive from different SOCs or organizations who participate in CTI associations. And of course, it questions the trustworthiness of all the associations that are involved in sharing data. And we plan also to validate the task force's work with bi-monthly meetings of the ad hoc working group, and identify also other interesting areas of for interventions. And there is going to be a call later this year from the Commission that will it will be a funding of around 130 million, if I'm not mistaken, that's going to be dedicated for SOCs, and hopefully some of our recommendations are going to be in this type of funding there. And thank you very much for your attention. This was my presentation. If you have any questions, I'll be more than happy to answer, and I really look forward to the most interesting part of the conference, which is your presentations later on. So thank you very much.
Thank you, Ioannis. A really interesting presentation and a lot of work we are doing in ENISA. So if there is a question, please open your mic. Okay, a question from my side. What we are all wondering is, how do you think that EU projects can assist in the work you are doing in ENISA, and how we can get involved apart from the working groups that you already have mentioned?
This is a very interesting question, Manos. We, unfortunately, at ENISA, we're limited in the ways that we could actually interact with the research community. There isn't a way to do research at ENISA. But what we can do, and we have been doing it successfully, is either, as you said, through ad hoc working groups to engage the research community, or we have seen also through different workshops that ENISA can participate, where Horizon 2020 projects are organized. We can identify areas of interest, and we can then form projects that we can work together. Another area that it is useful is for ENISA to be part of the advisory group of a project, for example, and there we can keep track of all the research developments that take place, and either contribute to the work directly, or we could actually streamline our activities and create projects that are pertinent to ENISA as well. Unfortunately, I don't have like a very clear answer to give to you, but these are the main three ways that I see that ENISA can be involved with the Horizon 2020 projects. Common workshops, ad hoc working groups, where you have the chance to actually shape ENISA's work, and also ENISA being part of the advisory group. There is also the potential for any Horizon 2020 researcher to be part of what ENISA calls as the CEI list, which is a list of experts that we utilize when we have different projects, and we get experts to assist us with writing different reports or providing different functionalities there.
Thank you. That was really interesting, all the information that you have provided, especially that you could participate in external advisory boards of projects. So I think we will be knocking on doors in the future. So thank you very much.
That would be fantastic, yeah. Because we're also like, insight into what Horizon 2020 projects are doing, and we need to collaborate closer together.
Yeah, exactly. And we need to align with your policies and your directives and the work that you are doing. So is there any other question, or can we start to the main part with the presentation of the projects? So I don't see any open mics. So let's move on to the next presentation. It's about the CyberSANE project. Our technical manager, Thanos Karatsias, a principal security solution architect from Maggioli Group, is going to be presenting the work that we have been doing in CyberSANE. So Thanos.
Good morning, everybody. Very glad to be here with you. And very glad to present you what we have done and what we are doing on the CyberSANE project. Wow, I need somehow to be able to share. Sorry for this. Okay. Oh, I need to restart. Sorry for that. I'm back in a few seconds.
Okay, no problem.
Back again, I guess.
Yes, we can hear you.
Okay, now I'm able to share.
Okay.
Are you able to see my screen?
Yes, yes.
Perfect. Sorry for that. Privileges on the application. The vision of the CyberSANE system is actually to be an innovative and a knowledge-based collaborative security and response dynamic system. It actually runs as a meta tool built on 5 different what we call CyberSANE components, and I will describe one by one what I mean. Our main intention in the project is to implement all the different phases of the cyber incident handling lifecycle. And this way, we would like to increase the agility of the security professional and encourage the continuous learning. The platform, as I said before, consists of several components, but among them, I would like to introduce the 5 most critical ones. And what I'm presenting is the real platform right now. And at the main dashboard, you can see the LiveNet component, the darknet component, the hybrid component, the sharenet component, and the privacy component. Visiting one by one, the LiveNet component is the one that is capable of preventing and detecting threats, providing to security professionals all required insights and the track record of the activities within their information technology environment. So this is mainly achieved by collecting in an organized manner event data from systems, such as installed devices, networks, storage, and streaming protocols. The darknet component in CyberSANE allows the exploitation and analysis of security risks and threats and related information from the deep and dark web. And this is realized via the analysis of both the textual and the metadata content available from various electronic streams in the deep and dark web. The hybrid component is expected to provide the intelligence needed to perform on one hand effective and on the other efficient analysis of security events. And this can be achieved in both ways. On one hand, on information produced and extracted from the component, the cyber component itself, and on the other, on information and data derived and acquired by other components, such as LiveNet or Darknet that we previously discussed on. So HybridNet undertakes the responsibility, first of all, to analyze a large amount of data derived from all other CyberSANE components in order to further evaluate and correlate attack-related patterns associated with specific malicious and anomalous activities within a critical infrastructure or an organization, further to investigate security incidents, especially when an event has been considered by the anomalies detection engine as such, in order to identify, evaluate, and propose mitigation steps for all vulnerability threats and risks associated with the security infrastructure. And last but not least, to identify all type of interdependencies at physical, system, and technological and business levels through the utilization of an attack behavior simulation environment that we will see later on. All this will eventually strengthen and significantly support the decision-making process, since the security professionals will be able to understand the technical aspects of an attack and draw conclusion on how to respond. The ShareNet component provides the necessary threat intelligence and information sharing capabilities of the critical infrastructure with external parties that the critical infrastructure would like to involve in this incident handling process, allowing these organizations and these parties to determine the trustworthiness of its information sources. So it is used as a secure and privacy-oriented storage as soon as the data is received, and create all the different policies required for sharing this content. At least the PrivacyNet component is responsible of managing and orchestrating, let's say, the application of the required privacy mechanisms, maximizing achievable levels of confidentiality and data protection. Actually, this component is responsible for setting up the security and data privacy policies, allowing security experts and members of the organization to specify all the protection steps and the required conditions to execute them. with all these different components, we can start building this security incident process handling process within our project, the CyberSANE project. And the main difficulty that we had to face, and we have to find solution, it was how we will eventually provide a unified digital environment in which security professionals maybe get advantage of all these different components and the functionalities behind all these components presented previously in one environment. So in the context of the project, we decided to be based on best practices and build the usage flows upon worldwide accepted recommendation guides. To this end, we finally adopted the NIST guide, and specifically the Computer Security Incident Handling Guide. According to this guide, the organization of an effective computer security incident response capability involves several major decisions and actions. And these decisions and actions are grouped in 4 different specific phases: the preparation phase, the detection and analysis phase, the containment, eradication, and recovery phase, and the post-incident activity phase. One by one, I will go through, and later on I will describe you in more detail each one of the phases and what we can support in the context of the project. I would like to just to introduce these phases. At the preparation phase, this is the initial phase which actually involves the establishment and training of all involved incident response teams, acquiring the necessary tools and resources for preparing the organization or the critical infrastructure for this incident process handling. So during the preparation phase, the organization attempts to limit the number of incidents that will possibly occur by selecting and implementing a set of controls based on the results of a risk assessment. At the detection and analysis phase, residual risk will persist even if controls are implemented in the preparation phase before. So detection of security breaches is necessary to alert the organization whenever incidents occur. Obviously, this is the core phase in which the CyberSANE project easily contributes based on its concept and on the list of components presented at the beginning of my presentation, and of course the list of tools that we have integrated behind to support and provide all this functionality. At the containment, eradication, and recovery phase, activity often cycles back to detection and analysis to see if additional hosts are inflected while eradicating the related incidents already identified from the detection and analysis phase. So at this phase, the CyberSANE project only contributes on the containment, since we don't have any tools or we don't provide any functionality or mechanism for eradicating and actually recovering the organization from specific attacks. But based on the evidences gathered from the detection and analysis phase, we can contribute on this containment process. And at the post-incident activity phase, this takes after all the previous mentioned phases, and after the incident is properly handled, the organization actually requires to issue a report that details primarily the cause and probably the cost of the incident and the steps the organization should take to prevent future incidents. All these different phases are properly supported in the context of the CyberSANE project, and let us see one by one what we can provide at each phase. So at the preparation phase, here the security professionals and the security experts within an organization or a critical infrastructure are able, first of all, to define the internal organization teams that participate probably in the incident handling process within the organization. So first of all, the security professional or the administrator of this dashboard may register all the different internal organization contacts, or even the external organization contacts that participate in the incident process handling. Secondly, and most importantly, the organization needs to register one by one all the different digital assets that need to be properly monitored within this incident handling process. So this is the inventory of an organization with one by one the assets. The security professional can easily register a new asset by specifying all the required fields for creating the asset. And here we have built a semi-automated process for taking the actual common platform enumeration number for each asset registered within our inventory. For example, if you have an SQL server, you can say that I have a Microsoft product. By selecting the vendor, all the products of this vendor become available to the security professional to select the proper and the very specific product of this vendor. So I have an SQL server, and upon selecting the product, the system brings all the available versions and the specific service package and patches for this specific asset. So by selecting this and registering this product, the system automatically communicates with open repositories such as the NIST Vulnerability Management repository, and brings automatically all the vulnerabilities that are registered right now for this specific product and version of the product. So this is a ground truth. This cannot be something that the security professional may not consider when preparing for this incident handling process. And with this process, you can see eventually that this is, for example, my this is, for example, my inventory. You can also define all the relationship of one asset with another and have this overview for the organization. Of course, with the same approach, you can define one or more controls. By controls, we mean mechanisms or even assets that are implemented within the organization and probably mitigate one or more specific vulnerabilities or specific threats within the organization. So by defining a control, you can say that this control, for example, mitigates vulnerability, and then it is related with this asset category or with this specific asset with a description and so on. And automatically, as I said before, the system once a day gets connected with open vulnerabilities repositories, brings the list of available vulnerabilities for all the different vendors, for all the different products, for all the different versions, and you have them available. Of course, the security professional is able to register zero-day vulnerabilities if this is the case, and attach it with a specific asset. And of course, the security professional is also able to handle and manage all the different threats identified for the assets of his inventory. For example, we can see here that the system says that you have already 75 CAPEC meter related threats related with the assets registered for this critical infrastructure. The most important step for configuring this preparation phase is to build the proper attack scenarios. And while building the attack scenarios, we mean that all the vulnerabilities identified from the system, all the threats registered in the system, and all the assets registered again in the system needs somehow to be correlated and build the proper attack scenarios. For example, you can say that this threat is related with this vulnerability and they affect this asset. By doing this, you can come easily and perform as many risk assessments as you prefer. So let us see what is the output of the risk assessment right now. First of all, you can see again your inventory, but now you can specify the level, the risk level for each specific asset. For example, you can see that my Ubuntu is in a risk level high, while my MongoDB is in a risk level medium, while my Docker is in risk level very high. And I can go one step further and have the full analysis of this risk by providing the heat map with the correlation of the vulnerability impact and the threat probability for each specific attack scenario built. And this way, the security professional gets aware of the current status of his infrastructure. Of course, the analysis we provide may be provided in several views with graphs. All the graphs are interactive, so you can have an overview of the current status and the output of the risk assessment. You can see in risk level again all of your asset with all the different threats and the interrelation with the vulnerabilities and so on. And this is actually more or less the preparation phase. By completing the preparation phase and providing the security professional with insights of the current status of its asset inventory, we proceed with the detection and analysis phase. In this phase, several different CM tools provided from the partners that participate within the context of the project are properly implemented and can be set up within each one of the organizations that are interested in using the CyberSANE platform. So at this specific example, 2 different CMs are already implemented in the asset inventory of this specific organization. And of course, you can see that we have already identified a huge number of anomalies, a huge number of security incidents, and these are analyzed in timelines and so on. So the security professional in almost real time gets aware of all the different incidents identified within his organization inventory. So you can have the exact list of security incidents identified with their full description of the security incident. In order to build an extensible platform and not be customly integrate with each one of the tools behind each one of the main CyberSANE components introduced in the beginning of this presentation, we have set an elastic common schema in which all tools may respect, and upon respecting the schema, they are able to easily plug in the CyberSANE ecosystem and provide whatever security incidents or whatever anomalies or whatever attack patterns they can identify within an organization. So till today, we have already integrated 13 different tools provided by the consortium of the CyberSANE project, but in the near future, we can have a huge list of tools integrated behind this environment. So the security incident in the detection and analysis phase is able to view the list of the security incidents, have a further analysis on the identified security incidents based on their severity, based on their type, and so on. And the same occurs also for the attack patterns and anomalies. These are the anomalies detected. These are the anomalies that are further analyzed within our system. So the security professional is able to have an almost real-time monitoring on the system. One step further, the security analyst and the security professional is able to set up and get advantage of the crawling mechanism that is already implemented within the CyberSANE project for the deep and dark web. So first of all, we can see what is the reputation of the organization at this time currently at the deep and dark web. So for this specific organization, we can see that no articles or no discussion have been identified in the deep and dark web. And currently, we have searched this number of sources. The security professional, so he can continue and perform a very specific search in the deep and dark web. So I want to see, in relation with cyber attacks, I want to see if there is any discussion or related articles with DDoS or denial of service articles, and within a given time range. So in order to further see what happens in this environment, the system automatically brings the most related articles with the keyword selected by the security professional, and of course it can provide the full articles and the full and the list of sources identified for this publication. So security professionals are able to further search for each one of the security incidents identified within each organization, his organization, so he can realize if something happens and maybe mitigation action needs to be performed ASAP within the critical infrastructure. Of course, we provide several graphs for analyzing all these huge number of articles automatically identified and crawl in the deep and dark web by providing the most important concepts in text, the cyber concepts in relation with critical score, in relation with the different URLs and sources that publish these articles. Again, the number of crawled URLs per date, and a huge heat map with the URLs and the scores for the different CyberSANE concepts. We can provide attack cloud and concept graphs. We further provide analysis with all the different sources that we are able to crawl, and how these different sources are related one with the other. So many different analysis here for the security professional and security analyst. But again, we can also provide...
Jako to umíme nadspat výsledky.
Again, sorry, I didn't hear.
I'm sorry, this was a mistake.
Sorry.
So I would need to stop you now so we can respect the agenda. So I will give you 1 minute to wrap it up.
2 more minutes. 2 more minutes.
Okay.
The same. We can provide. We can search the open web again with articles and so on. And at the simulation environment, what we can offer based on the evidences of the detection and analysis phase is we provide a simulation environment for the security professional to build attack scenarios. For example, if I have my entry point, the Node.js, and my target point is probably the Ubuntu OS, and the attacker skill is high, I can generate and see what are the possible attack paths within my organization, and how this attacker will be able to reach the target asset within my organization. And we can see here that the attacker will start from the Node.js, the entry point. He will be able and capable of exploiting this vulnerability, and the description of this vulnerability is this, and get full privileges on this asset and continue with an interrelated asset and reach the Ubuntu, for example, asset by exploiting this vulnerability and so on. So I can have multiple different attack scenarios that probably will help the security professional to take the proper decisions. And last but not least, the attacker, the security professional is able, based on the evidences gathered from all the different phases, to build as many lessons learned are required by specifying or not specific assets, specific controls, specific threats, specific vulnerabilities, anomaly security incidents, and attack patterns. And these security incidents may be shared with organizations outside and entities outside the critical infrastructure, or even cyber aware repositories such as the CyberSANE MISP or the Concordian MISP, in which we are already integrated and share all these lessons learned with the evidences. For this sharing process, we can specify specific privacy policies that need to be applied, for example, for anonymizing the asset IP, or for anonymizing the exact an exact attribute of the security incidents of the security incident. And that's all. Sorry for getting some time more than the one that.
Thank you, Thanos. It was a really nice presentation as always. Please, if you have any questions, you can write them in the chat so Thanos could reply to them. So let's move forward to our next speaker, Professor Sergian Skribic from University of Novi Sad, technical coordinator of C4I IoT project. So the floor is yours.
Yes, thank you. I will try to share my presentation.
Did I get the name?
By the way, yeah, you did very well with my name, which is difficult to pronounce.
Okay.
Okay, you should see my screen now. I
No,
hope that you see. No?
no, we cannot still see it.
Yeah, I'll try to do this again. Yeah, when I click share, nothing happens.
Okay, I could share for you if you like.
But I would need then to send you the presentation. I don't know why, but then I will send the presentation.
Let me.
In my case, however, it asks for privileges. If you have a Mac, you need to give privileges for the presentation mode.
It doesn't ask me anything.
Okay, I made you presenter. Maybe you can present now.
Huh? Okay. Okay. Just a moment. Oh, it says that I need to restart the browser, so give me a minute.
Okay, okay.
Okay, I hope that I'm back now. And
Yes.
yes. And it says that I'm sharing the screen, so you should see it now.
Yes, it's not in.
Yes, it's not in. Great, then I can. Then I will start. Okay, I will present the C4IoT project. It's cybersecurity for protecting the industrial Internet of Things. Here's the link to our website. I think it's important. You can find a lot of material there, including some live demonstrations, videos, okay, the public deliverables, and so on. So I think this is well-maintained website and a good source of information. Okay, C4IT project, its domain is in the industry 4.0, which is based on the digitalization of process, as you know, and interconnection of the equipment. And it's focused on cybersecurity challenges that arise in such scenarios, targeting the protection of IIoT, so Internet IoT systems. So we begin everything with the IoT, Internet of Things devices. The framework architecture is chosen to cover the most representative use cases in such an industry, and we have two use case demonstrations in the automotive sector. I will go into much more details about that. So just for the sake of reference, this is our consortium. We have partners both from academia and industry, and use case provider is the Fiat Research Center that actually changed the name to Stellantis, changed the name and organization during the project to Stellantis. So it's an old name here. Okay, so I will just present some basic objectives of the project and then perhaps present architecture and some details of how the framework works. So C4IT is a cybersecurity framework that implements security enabling solution with the aim to minimize the attack surfaces in industrial IoT systems. It says here that we will design, but the project is close to its end. So we did design, build, and demonstrate such a framework, novel cybersecurity framework, that implements an innovative IoT architecture. So we're actually in process of publishing a serious scientific paper about that, about the innovativeness of the architecture. I will present some details of it later to provide as a basis for the framework for security enabling solution. And here are some of the methods, some of the technologies that we use within the framework. So we use machine learning, deep learning, various algorithms for machine learning and deep learning that are used to detect anomalous behavior, to say so. Edge, cloud computing, blockchain, big data technologies, and so on. Okay, our use cases. So our demonstration is aimed to the automotive sector, and our use case provider is a large facility, so a large partner from the automotive industry, and we have two use cases that we wanted to demonstrate, that we focused on, that we did demonstrate actually. The first one is the application in inbound logistics, as we call it, or you can call it logistics 4.0, because there's again this digitization of processes that then tackles the problem of how to manage shipment of different car parts, automotive parts from various origin points to manufacturing plants. And the IIoT is a key technology here to enable the optimization of logistics along the supply routes, supply chain, to maintain low stocks along the supply chain and inside the plant, as we will see. to reduce working capital, warehousing costs, and so on. So in this use case, we can imagine those large containers that are used for the shipments that contain various automotive parts, and they travel around the world with various means of transport. And we would like to track and detect potential anomalous behavior of every single individual container. So we use IoT devices for that. Within the project, we designed a custom IoT device that is attached to the container. So the problem here is that there's no power supply, so we have to rely on battery. Battery should last, okay, we aimed for at least a month, but in the tests are showing that it can even last 2 months. So this device is a microcontroller, some kind of very powerful microcontroller, but it's still a device with low processing capabilities and low memory. Since we don't have a power supply for them, we had to use those. Okay, I will describe later when we go into the architecture what happens with those IoT devices and the containers, but that's the setup. In the other use case, here we are in the smart factory, in the factory, so we can imagine multiple factories with various kinds of devices. And in this case, we don't need to rely on a battery. We have a power supply within the factory. So in this case, the IoT devices are Raspberry Pis, so single board computers. They are some kind of small computers, but with much larger processing memory capacity and processing power than those microcontrollers in the inbound logistics. And they're attached to various machines in the plant, in the smart factory, AGVs, robot hands, and so on. And they're usually connected to the rest of the system using Wi-Fi, since there's a Wi-Fi within the factory, or even the Ethernet, the cable network. While, yes, I forgot to mention that in the logistics use case, IoT devices, you can imagine a container on some ship somewhere at the sea, hopefully where we have a mobile phone network, we can use narrowband IoT. So they're using a novel technology that's narrowband IoT to connect to the rest of the system. We will see what the rest of the system is. But in smart factory use case, that's just a computer network, so Wi-Fi, usually Wi-Fi. Okay, here is the up-to-date sketch of the architecture. There are too many arrows and too many components to cover them in this presentation, but we can describe some details. So first of all, there are 3 layers. There are infrastructure layers. I just described the first layer actually. I hope that you see my pointer, so it's down in the bottom of the slide, edge node layer, where we have trucks where those containers can be loaded to ships, to trucks. Our test cases are with trucks carrying the containers around Europe, and they can be in the warehouses. So this box here represents the logistics use case, the use case with the containers, and this is the other use case, smart factory. So this is the edge node layer, and we have IIoT devices here. It communicates with the field gateway, field gateway layer. That, in the case of logistics use case, is a mobile network of the mobile operator that those devices connect to, and there's a field gateway server within this network. And in the case of smart factories, it's a field gateway server within the factory. So connection here is just Wi-Fi, and this is the next layer of the infrastructure with some components, some other components here. Some of them we will describe. And in the upper layer, all the rest of the picture is the cloud. So there's just one cloud that's the center point of the whole framework, containing most of the components of the system. So that's the horizontal division, infrastructural division, and that's what we use the most here to describe the system. But there are also levels. So these were layers. There are also levels. You can see here, level 1 is hardware-enabled security. So this is what happens in the hardware, in the devices, using some chips provided by IFAG, Infineon, and some secure environments provided by Ford. So this is what happens in the devices and stretches through the first two layers, actually. So devices in the edge node layers and the field gateway layers. The second level is the communication between those devices. Security by horizontal device communication, again stretching to the first two layers. And the third level is what we call security by machine learning based behavioral analysis and cognitive security capabilities. And this level 3, this security of the whole system, stretches through all three layers. So we have some machine learning based anomaly detection or behavioral analysis, even here in the edge node layer. And in the upper layers, field gateway and cloud layers are we have more powerful machines. We have more powerful methods for detecting cybersecurity incidents. Also, so this should be the brains of that. So advanced anomaly detection. There's this. So if there's a detection of what's going on, of incidents, cybersecurity incidents through all three layers of the architecture, but then there's when an incident is detected, then there's a reaction, automatic reaction. So one thing is it's this component here, advanced visualizations, that's not connected with the layer with the arrows, since we would have too much arrows. But one thing is to visualize the threats to some operator that will then react. And the other thing is the mitigation engine. So the engine, so it's this part that would analyze the threat and create a mitigation plan and take action, which is usually shutting down some parts of the networks using the SDN controller or a reaction like that to prevent further anomalies but only in that part of the system where the anomaly happened. So this is yeah, in the time that I have, I think this is the that I cannot go into much more details than this. But we can still, I would like to again go through the all three layers again with a bit different view of what happens within the layers. So this is the edge node layer in a bit more detail. So this is logistics use case. These are microcontrollers attached to containers that are loaded in the trucks or warehouses. So this is logistics, and this is smart factory use case. So in this case, we have single board computers. Okay, they have some kind of shield. I will explain that. Attached to various devices in the smart factory. Okay, and they use different communication channels. These microcontrollers have SIM cards and they use mobile phone network, NB-IoT, narrowband IoT, while these devices use just Ethernet LAN connection. So it could be a cable, it could be a Wi-Fi. But even in this edge node layer, we have some kind of anomaly detection. Okay, these Raspberry Pis, they have, I think, 0.5 GB of memory, and they have some ARM processor capable, still capable of running some kind of lightweight anomaly detection models. That's, I think, easy to understand. We can run Python programs on them. So there's some kind of anomaly detection here, but also within these microcontrollers, we wrote some papers about that. We implemented in C, programming language C, some routines for anomaly detection using autoencoders. So we cannot call it deep learning since they only have one hidden layer, but they're neural networks running in microcontrollers. Okay, a bit more powerful than the other microcontrollers, but than usual microcontrollers, but they're still microcontrollers with very little, small memory capacity and small processing power. So these detection capabilities, anomaly detection capabilities, are in the firmware of those devices implemented in C. So we have some anomaly detection, cybersecurity incident detection, even in the edge node. And all these programs that I described run in secure environments provided by secure execution environment. That's secure environment provided by Fort based on Intel SGX instructions. Infineon provided OptiGA-Trustix chips that are used in both of these cases. That's this shield. And SIA provided BINSEC. It's a tool that checks if the firmware of the device has not been tampered with and if the code is safe to run. So that's a basic anomaly detection at the edge node layer. In the field gateway layer, now we have edge node here. It's similar. We have microcontrollers here, but in the smart factory use case, we have single board computers. It's the similar thing. They're all connected to field gateway server in mobile network operator network core. So in the safe server, it's a server in a safe environment. That then has much more processing capabilities than those devices in the edge node layers, much more even than Raspberry Pis, of course, and a lot more than microcontrollers. And then, okay, what's detected in the edge node layer is detected. Whatever we detect, we have some confidence score. If the confidence score is high, that's okay. If the confidence score is not high, then additional analysis are run in the upper layers. So in this layer, we run additional anomaly detection routines. And then there's this component, Medici, security-aware dynamic offloading decision mechanism, that takes into account those parameters and decides if data needs to be offloaded to the cloud for additional, for the third layer of inspection, that's the most powerful and that contains the most powerful routines for that. And this is then the cloud layer. So if a data is offloaded, it would be offloaded here in this part. And here we use the most advanced. Here we really use deep learning, so really deep neural networks. They're okay. Most of them, we mostly use autoencoders, some kinds of autoencoders to detect anomalies, but also some other methods that are mostly time series analysis and so on. For instance, we had some very good results, and we used that with Facebook Prophet. It's a library provided by Facebook that's used for analysis of time series, and this is actually time series that can detect the behavior which is not usual. And so on. And it's all run in security environments, and through all the layers, whatever happens, so every incident, every detection is then reported to the blockchain using AB for communication and so on. So that's this part. So everything is stored in the blockchain. And one other thing worth of mention in this detection part is usage of differentially private methods. So we have, for some scenarios of usage where the data is there's a risk of privacy breaches. We have implemented some machine learning methods, I think 4 or 5 of them, I'm not sure how much of them, as differentially private methods that then make the analysis in a privacy aware way. And as I said, if in case of detection, okay, we don't have all the arrows here, but in case of detection of anomalies, information goes to this security assurance module that then communicates with a high-level reconfiguration search. So this is a key component, karmas. I'm not sure what's the exact abbreviation, but this is a component that decides what to do in case of an attack using some advanced analysis. Yeah, I don't want to go into those details, but you can find the details again in the both for this and for the whole anomaly detection scheme in the public deliverables that you can find on the project website. And of course, in some publications, there are also publications listed. And I think even PDFs, since they're all open access, that you can find PDFs of publications, I mean papers in conferences and journals in the website. So I don't want to go into much more detail here, but so when this component decides what to do, then it uses what we've seen here in this picture, SDN controller that we call Disco to then shut down the parts of the network where the anomaly is detected, and to visualize what happened, to show what happens to the operator that would then make further action. Okay, yeah, I think this last slide is what I already described. It's what goes on in levels and layers. So yes, I would end my presentation here. I would maybe leave this slide open if there are some questions.
Thank you very much. I think we have time for one question. Okay, thank you again for your presentation. Please post any questions in the chat, so there could be some interaction between the speakers and the audience. Also, if you would like to post the website of your project in the chat, so the rest could follow, that would be great.
Okay, I will do that.
So if you like, please open your camera when presenting. That would be great, if you are okay with that, of course. So let's move on to our next project, the Caramel project, an AI-based cybersecurity for connected and automated vehicles. It's going to be presented by the technical coordinator of the project, Peter Hoffman from DTSEC. So the floor is yours.
Okay, hi. Peter Hofmann is my name, from Deutsche Telekom Security. So I will start sharing the screen. Actually, I'm 2 times in the conference, so that I will be able to show you some result videos, because the presentation that I've just opened, it's mostly the same as from the first joint workshop. And I think the focus of today's workshop is to actually look at some of the results of the project. So it will be structured a little bit different. We'll have one slide, one pager to recap the goals and the pillars and the partners of the project. And then we go into medias res and look at the results that we have achieved. And our partners have prepared quite a lot of interesting videos that you can also replay later from our website. And I can also later send the link to our website to the chat. So to the overview of the Caramel project, on one page, the idea of the Caramel project is to employ machine learning or artificial intelligence, but it's really machine learning techniques to detect and allow the mitigation of threats and attacks against the connected vehicle, against the semi-autonomous vehicle, and also in pillar 3 against the e-charging infrastructure for electric vehicle infrastructures. And we have Korean partners. There's an affiliated project that's at the same time it's conducted in Korea, but it's of course not financed by the European Commission, but by the Korean government, and we exchange information and technical details with our Korean partners. So the results, and we'll see quite a few of the results today, is detection of attacks against the sensors of the car, against the vehicle-to-X communication, that is communication between the vehicle and other vehicles, as the roadside infrastructure or central services. We have detection mechanisms for GPS spoofing, and we also can detect attacks on the e-charging network. Yeah, from our side, actually, I want to mention it. The anti-hacking device that comes from Deutsche Telekom Security, and that is an intrusion detection hardware module, a hardware and software combination that also has machine learning capabilities, and that will be mentioned in the result videos quite a few times. And that is meant to be integrated into the vehicle as a security co-processor, you could say, to detect onboard attacks against the car. And we also have an integration with back-end systems to bring all the different pillars together. So yeah, that's actually the overview. That's yeah, all of the slides that I want to show today. Of course, all the 15 slides, I can make them available to the participants of the conference today. But I think it doesn't make sense to repeat all that I already presented during the first workshop. So let's go to the Caramel website. And I hope it works now with the transmission of the audio. Yeah, maybe start with a short overview video so that you can get some more information about the 4 pillars that I talked about briefly just a moment ago.
Caramel, artificial intelligence-based cybersecurity for connected and automated vehicles. Vehicles are becoming smarter and greener through connectivity and artificial intelligence. Hence, cybersecurity is emerging as a new concern, able to stop such huge potential for more sustainable, safer roads with zero fatality. Caramel's goal is to proactively address modern vehicle cybersecurity challenges, applying advanced artificial intelligence and machine learning techniques, while continuously seeking methods to mitigate associated safety risks. The EU-funded Caramel project is developing cybersecurity solutions for the new generation of vehicles, addressing 4 main pillars: autonomous mobility, connected mobility, electromobility, remote-controlled vehicles, attack on sensors. These attacks do not require any physical access to the vehicle or tampering with the communication system. Attacks via data and interfaces. V2X applications interconnect not only vehicles but also infrastructure and pedestrians. Hence, it is critical to protect V2X functions from a misuse. Attacks via e-infrastructure. Unauthorized access and control of EVSE stations and firmware modifications should be prevented at all costs. Attacks via remote control station. Intrusion detection and estimation algorithm in the gateway and remote-controlled vehicle is necessary to avoid misuse. How to address all of those scenarios? Artificial intelligence techniques will be used to model cyber threats, detect cyber attacks, and to identify appropriate responses for each of the main pillars addressed by Caramel. An anti-hacking device will be trained using machine learning techniques. Once deployed, it will disable higher-level functions in case of a cyber attack. We invite you to watch the demonstration videos. Pillar 1. Autonomous vehicles. Traffic sign anomaly detection and mitigation pipeline. Attack detection and mitigation techniques for the camera sensor using a deep learning approach. In-vehicle location spoofing attack detection. Holistic situational awareness with ML application. Pillar 2. Connected vehicles. Roadside unit, RSU, and onboard unit, OBU, testbed. Collaborating mitigation mechanism against GPS spoofing.
Okay, that was a very high-level overview, recapping maybe some of the points that I made during the short presentation. But now I would propose that we go into the different pillars, maybe starting with pillar 1, and that is the traffic sign and mitigation pipeline that also the overview video has talked about. And yeah, now let our partners speak.
In this video, we demonstrate the anomaly detection pipeline with a mitigation strategy. The traffic sign anomaly detection and mitigation pipeline consist of 4 deep learning networks. They are traffic sign detection, traffic sign anomaly detection, traffic sign reconstruction, and traffic sign recognition models. The flowchart shows the overall pipeline. First, the pipeline takes in full HD image 1920 by 1080 resolution image from Kala simulator and detects the location of traffic signs. The cropped traffic signs are then pre-processed as required by the anomaly detection model. Second, the cropped traffic signs are input into anomaly detection, and if the anomaly is identified, then the traffic sign is forwarded to the reconstruction model. The reconstruction model generates the clean meta traffic signs without anomalies. Finally, if the anomalies are not detected, then the traffic signs are input to the recognition model, or if detected, the clean meta traffic signs are used for recognition. Next, we show the GUI for the pipeline. The GUI consists of a visualization panel at the top left-hand side. In normal scenarios, the panel contents capture traffic sign, total number of traffic sign, and traffic sign label. Likewise, the green bounding box in the image highlights the location of the detected traffic signs, and color green means no anomaly has been detected on a traffic sign, whereas the red box means the anomaly has been detected. In abnormal scenarios, the panel contains additional information such as total number of anomaly traffic sign, attack traffic sign, anomaly traffic sign localization, reconstructed traffic signs, and the label of clean traffic signs. Likewise, the green color text indicates that the label is derived from the normal signs, whereas red text means the label is predicted from the meta traffic sign. Next, we show the real-time outcome of the pipeline. In the demo, 3 traffic signs were included, where 2 are attack traffic signs and 1 is a normal sign. Once a traffic sign has been detected, the anomaly detection model tries to identify if the sign has been attacked or not. Once confirmed, the traffic sign is highlighted with a red bounding box.
So that has been a video of an attack on the sensors, the camera sensors in this case, of the vehicle. Maybe now go to pillar 2 when it comes to the vehicle-to-X communication. And the video that I'm about to show shows the roadside unit, onboard unit testbed, that highlights the work that is done in the Caramel project on attack detection in this vehicle to X scenarios.
Hi everyone, this is Bruno from I2CAT, and today I'm going to show you the current status of the Work Package 3 scenario that we are deploying here in I2CAT. So we have here 2 geographically separated areas, which consist of 1 OBU and 1 RSU in each of them. And finally, there is a MEC server, which is currently a Raspberry. So between the OBUs and the RSUs on each area, we are currently separating the channels. So for instance, in this region, they are working on the 180 frequency. On the other side, frequency 178. So this way, both OBUs cannot see each other directly, unless there is a MEC server on the middle, as we will see later. Okay, so from all these cables, we have on both OBUs using Ethernet for the debugging purposes, and then the RSUs are using Ethernet cables to the MEC server, simulating somehow fixed broadband service. So now what we're going to see is from left to right, we're going to see the OBU number 2 transmitting CAM messages to the OBU number 1, going through the RSU number 2 to the MEC server, and then to the RSU number 1. So on the left side, on the terminal that corresponds to the OBU number 2, we can see that we are sending CAM messages digitally signed using a local certificate, since right now there is no PKI infrastructure. Let's start this. Okay, so it's now transmitting CAM messages, and then on the right, on the OBU number 1, if we start a TCP/DAM capture on the OCV interface, which is working now on the 5.9 frequency, we will see the broadcasting messages from the RSU number 1. These OBUs that we are using are based on motherboards called APUs, as you can see, and they are not the final solution to use as an OBU. Final OBU will be provided by Ficosa, and at the moment we're still working with this evaluation kit from Broadway. Finally, we're also working on the LTE setup, and at the moment we have this small cell from Accelerant.
Hello, Peter. We cannot hear you. So I think there's something wrong with Peter's microphone, or so let's move on to our. Okay, I think he's trying to reconnect.
Yeah, okay, here I am again. Sorry, my second device where I've been talking and trying to talk actually disconnected. Sorry for that. Actually, a little bit over my time, but I think since the previous presentation took a little bit longer, maybe a few more minutes, maybe one more video. Is that okay?
Yes.
Okay, yeah, actually, when looking at the video, I think I should have given some context beforehand to the videos that we've just seen. And yeah, this specific scenario is about the interoperability between the two different vehicle-to-X standards. Now, the one is the cellular vehicle-to-X standard, CV2X, and that is the reason that we are deploying these LTE small cells from Accelerant that you've seen at the end. And there is another technology which is DSRC or 802.11p, I think. It's an abbreviation. That's Wi-Fi technology. And some car manufacturers actually are going in the direction of cellular vehicle-to-X. Others use Wi-Fi vehicle-to-X. And the proposal in the Caramel project is to use multi-access edge computing nodes, MECs, to actually translate between these two different technologies. And also the MEC can then, of course, be used to do some sort of security evaluation of the vehicle-to-X transmission. And that is the reason that we are doing that in the Caramel project. And the videos that I've just shown shows the progress along the way to implement that solution. And we will actually have in June in the German city of Hanover a real-life demonstration, no? Where we have all these technology built up on a parking lot of one of our partners, and also have a car with the OBU installed. So that's progress on pillar 2. And yeah, maybe we should also go back to pillar 1, because there's some very interesting work now, mostly done by our partner Panasonic, now, that looks at some more attacks on the image sensors in the car. And maybe that's the last video. Now, I'm obviously don't have time to look at all the videos, and maybe leave some time for questions later on.
This activity involved detecting possible attacks on the camera sensor using a deep learning approach. In this scenario, we considered an attacker manages to alter the output of the camera by adding noise and malicious content that deteriorates the image quality. This has as a result the integrity of the whole system to be compromised. Therefore, the problems that arise are how to recover the content of an image, which was addressed in WP3, and if it is possible to detect as an attack, a problem which we address in this activity. To devise a detection strategy, we utilize a convolutional autocode structure developed for the purpose of task 3.2 in WP3. We can train such a network so that it forms an entire representation of the image content for reproducing the input as closely as possible, so that when it is given an image that was manipulated with noise, it can reconstruct it to be as close as possible to its initial unaltered version. Moreover, the autocoder is expected to learn the features of normal images so that the output will be an accurate reproduction of the input. On the other hand, when a noisy image is provided, the autocoder will reconstruct the input image, mitigating any distortions. We can then exploit this for a detection pipeline that examines how similar the input and the reconstructed images are. A big difference between the images will indicate an anomaly. The detection pipeline developed for the purpose of task 4.2 uses similarity metrics between the two images to train machine learning algorithms so that when an anomaly is detected, the mitigated image is sent to the perception engine, while in the other case, the original image is sent. The Kerala simulator was used to generate multiple data for the training, validation, and testing phase of the algorithms. The data were gathered using various weather conditions in different towns available in the Kerala simulator. We trained the machine learning models using normal data as well as by generating attack data without the noise of different types at different strength levels. In the demo, you will see a car navigating in the Kerala simulated environment through the images received from the virtual camera sensor. Attacks will be added randomly, which the autocoder has to mitigate. The detection pipeline will attempt to detect the attack and propagate the reconstructed image. In the case of an attack, the framework outputs the reconstructed image. In the opposite case, the framework outputs the input image. The video will display two images, the input and the mitigated view. We show the prediction of the detection, an indicator for whether an attack is actually happening, an indicator for the predicted severity of the attack. In the reconstructed view, whenever the reconstructed image is chosen, a sign also appears indicating that the indication has taken place. In addition to the detector framework, you can watch the behind the wheel view on the top left window. At the bottom left window, you can see the semantic segmentation result using the output image FAR framework. You can observe that the semantic segmentation is robustified, as even under strong attacks, the scene perception is not compromised. Our framework is trained to mitigate attacks of two different types. Methods of attacks that involve the traditional noise models such as Gaussian, Becquerel, salt and pepper, and Poisson were added. In addition to this type of attacks, the model is able to reconstruct the images distorted through the addition of artifacts, such as stacked lines and blank regions. We implement different attack detector approaches based on either statistical methods or deep learning extensions to our autocoder. The performance is excellent, ranging between 97 and 99% accuracy.
Sorry. Yeah, that was just a very short look into the different outcomes. As you can see, there are more result videos on the Caramel website. As I said, shortly after my presentation, I will send the link to the website. You can head over to the multimedia section and yeah, maybe rewatch or watch the other videos that we have, and that number of demos will be extended in the following months until the end of the project in June. There will also be a video from us on the security features of the anti-hacking device, because if you introduce a new device into a vehicle, you don't want to have another attack surface opened, so it must be very secure if it's a security device, and we will have some information on that. Yeah, I was not able to cover all the aspects because it's a very large project with many different partners, and we have quite a lot of results now nearing the end of the project. But maybe we have a few moments for questions. Are there any questions?
So,
okay.
Yeah.
Yeah, if not, you can always drop me a line, and we have maybe also have kind of a meeting if you need some more information. So that's an offer from my side. And then it's from me.
Thank you very much for your interesting presentation, and you have done a lot of hard work. Thank you very much. So now let's have a coffee break of 10 minutes. So see you back in 11:15. Also, I would like you, if you like, when we come back, we could open cameras to take let's say a family screenshot of the workshop to disseminate for all the projects. And after the coffee break, the next project presenting will be GUARD. So thank you very much. See you in 10 minutes. Okay, I think we had some time to stretch our legs, get some coffee, so we can go on with the rest of the agenda. So the next project in line is GUARD, a cybersecurity framework to guarantee reliability and trust for digital service chains. And the presenter would be Matteo Reperto.
Yes.
Yes, Matteo? You are the technical coordinator of the GUARD, right?
Yes.
Okay. So the floor is yours.
I'm trying to share the screen.
We can see your desktop.
Okay. Can you see now the presentation?
Yes, yes.
Okay. So I'm talking you about GUARD. We are a consortium of several partners from all around Europe, and we are 15 partners from 8 different countries. We are mainly a consortium of experts in networking, cloud computing, and partially in detection and analytics aspects. So basically, what is the main concept for GUARD? We started from a simple consideration, which is that current CM models are a bit outdated because they often assume the presence of network hardware and software as the main sources of information. But this basically neglects a large amount of important assets, which is represented by the cloud. Of course, there is not only the cloud, but there are cloud applications, data stores, and also functions in a PaaS and serverless environment. So basically, our understanding is that, okay, there are already some tools to deal with this environment, but probably they are not enough to address the complexity and dynamicity of this environment. And basically, there are also different roles with respect to the past, which are resource providers, like cloud providers that provide the virtualized resources. There are service providers that compose multiple services together, for example, a cloud application with an IoT devices, or a data store, or something like that. And finally, security providers that are third parties that provide security services. So just to give you a simple example that follows one use case that we are developing in our project, you can think at the scenario of a digital city, where we can have multiple IoT devices scattered around the city, for example, on buses, at light signs, at lamps, and so on. We can collect this information from LoRaWAN gateways, and we can provide this information. We can push this information to the cloud through a dedicated backbone, or maybe also a rented 5G slice. And in the cloud, usually there is the LoRaWAN network server, and also an application to provide services to the final user, the citizens. In this scenario, we can identify a number of different domains that in some cases could be provided by the same organization, but in many modern business cases, they are provided by different organizations. For example, there are some organizations that own the IoT devices. There are organizations that could provide the LoRaWAN connectivity, and also 5G slices are provided by a different network provider, usually. And the cloud providers can be other different organizations, and also the same applications in the cloud can be provided by different organizations. So, okay, it is possible we have interfaces available today to compose these systems, but we don't have effective and efficient cybersecurity mechanisms to provide visibility over all of these resources. Basically, what are the main problems, the main challenges in this case? Well, we can consider a lot of resources, and we can take into account applications, devices, infrastructures, and the connections between them. The first big issue is the composition of applications, cloud services, network slices, and smart things into service-oriented architectures. This obsoletes the traditional security perimeter model, because there is no more physical boundary to the service, and these services are composed over the whole internet. Another issue in this case is the usage of more automation in security processes, so to avoid the human errors in design, implementation, configuration, and management. It is also difficult to guarantee the integrity and trustworthiness of the whole chain, the whole service chain, because a vulnerability or a breach in the weaker link can become a privileged attack vector to reach other services and processes in the same application. And it is not a coincidence that small devices and smart things are even more preferred targets for initiating more complex attacks. And finally, one thing that is not considered today is the presence of unknown topologies at the design time, because the services are composed at runtime. They can be changed during the service lifetime because of the unavailability of one infrastructure, or because a better infrastructure is found that provides the same services, and so on. So this raises the questions about the overall behavior of a system, the location of data, the sanity of the software, the availability of the service, and most of all, the ability to perform quick remediation and mitigation actions in case something goes wrong. So basically, the main problem for GARD, the main concept for GARD is to provide a new way to gain visibility over these complex systems of system, as they are often called. Of course, there are already some solutions that deal with cloud. For example, cloud asset security brokers, but they are mainly considered as policy enforcement centers. So a way to define consistent policies for the organization and to apply these policies on all resources, both the resources within the, inside the same organization and the resources that are deployed in external clouds, for example. But basically, they work on resources owned by the same organization, while in many cases, service providers build their applications and services by composing services from other external organizations. And so this is not covered by this kind of solutions. What are the problems of CISSP? The first one is that they are brokers of heterogeneous interfaces. So, okay, they can give you a uniform view, but anytime you need a different or an additional interface, you must add something to your tool. You need continuous updates of your tool. We are unable, as I said before, to manage third-party services because they don't take into consideration usually the need to authenticate and to access the resources that are not owned by the same organization. And another big issue is the static configuration. So they are not designed to address the changing environment where different services can be used in a service-oriented architecture. So the problem of visibility over these different kinds of resources is that the service provider, which is the entity which owns and manages the service, has only limited visibility over the resources he usually uses to provide the service. Full visibility over such resources can be only the resource provider can have a full visibility over these resources, and he usually is not willing to give such visibility to external users. So basically, the GARD platform was born to address this kind of issues. Basically, what we have in mind is to provide a platform which is able to run detection and analytics services, basically a security information and event management system, but that is more configurable and more elastic to adapt to different devices, services, and whatever else. And the focus for the GARD platform is the platform itself. So I mean a sort of middleware between the detection algorithm and the environment, which should be in some way dynamically discovered, and the data should be collected and processed in a very flexible and configurable way from the platform itself. So there are three main objectives for GARD. One is to give programmatic assets, security capabilities embedded in the execution environment. And this is necessary to give visibility to the security provider. And the third issue is sharing this information with the rest of the world. From the standardization perspective, GARD is interested in a common way to expose the security capabilities and data, and on the other side, a common way to describe CTI. In the GARD ecosystem, as I said before, there are multiple stakeholders. The first one is for sure the security provider, which usually operates a security operations center. The security provider uses applications, detection applications, and analytics engines provided by some cybersecurity vendors, and he uses these applications to analyze the data that come from multiple resource providers on behalf of a service provider who owns, creates, and manages the service as a whole. There are also other stakeholders in this ecosystem, which are represented by end users, because they usually put their data inside the service, and they would like to know where their data are in each moment and who has access to their data in a full service chain. And of course, there are certain networks that should share the information from the system. Okay. So, based on this main concept, we built an architecture, a software architecture for the GUARD system, which includes a number of components. The unique feature, the unique characteristics of our architecture is that we don't assume that the security provider owns agents. We assume that we have a core platform where the security algorithm runs, and that we have standard interfaces to use security capabilities exposed by resource providers. So we assume that similarly to what already happens for management purposes, the public digital services offer also a security interface that gives the possibility to run some inspection, monitoring, and enforcement process locally. Of course, there must be some limitations to what can be seen. The visibility should be limited to the resources owned by the service providers and not to resources used by other tenants. And so it is not simple to solve this problem. We provided our solution, and also tries to make the system very, very dynamic and configurable. We basically create a closed control loop over this system. We basically start by defining policies in a dashboard, in a user dashboard. The purpose of the policies is to define what kind of detection service we want to implement, and give a responsibility to an automation engine, which is called the security controller in our architecture, to take care of the configuration of the full system, including the remote agents and so on. We then collect the remote context by, let me say, common methods. We use the Elasticsearch for this purpose, and Kafka, Logstash, Elasticsearch. And okay, all the information is delivered local in the core platform to a set of algorithms that perform detection and create events and notifications. Both raw events from the agents and the notifications from the algorithm are then shared inside the platform, so that the security controller can automatically react in some way to threaten attacks, for example, by changing the current configuration of the agent, by applying some enforcement, and so on. What are the main achievements we had in this project? The first one is the discovery of security capabilities. So we built a preliminary information and data model that we use for exposing the security capabilities. This is one thing that was totally missing in the standardization landscape. This afternoon, I'll give also a brief overview of some standards for this kind of things. And I'll show you how with the standards lack this kind of features that we need in this case. So basically, this interface is useful to have the picture of the full environment, so to discover the services that are linked together to create some value-added chain. It can discover the security capabilities in terms of monitoring and inspection processes that are available, and it can also describe the environment itself. So if it is a cloud infrastructure, what kind of software it is deployed in this infrastructure, what kind of applications, and so on. Of course, this is useful to understand, to have a full situational awareness and to have the ability to discover vulnerabilities, to perform risk assessment, and to apply the correct security strategies. We have a dashboard for all of these purposes. For example, this is a screenshot of a dashboard that show how a complex service is discovered. This is not representative of a use case I showed before, but in any case, the main idea is to represent the different resources that are used together with the availability of security agents in each resource. The second important thing that we did in GUARD is the possibility to create security analytics pipelines. This is basically the configuration of the detection pipeline, starting from the selection of available agents in the different infrastructure, the selection of the proper algorithm to perform the analysis of such data, and the definition of mitigation and reaction policies that automate response actions to specific events. We have this feature in the dashboard. So basically, after we discover the available agents, we can select them, we can connect them to an available algorithm, and the system, the security controller takes care of configuring it in an automatic way this security pipeline. This is one feature that is missing to many current products, because usually there is the need to configure manually the security agent, or at least to configure manually the different environments where the agents are deployed. And so, this is very useful to automate the management of security processes. And the automation is made through, of course, we cannot take into account any kind of different processing pipeline. We have a model in mind, a model which is represented by an agent as the primary source of information, the possibility to perform some local indexing, transformation, aggregation tasks. Then we have the possibility to collect data to a dedicated topic. We have, again, a processing phase in the centralized platform, which is mainly responsible for indexing of the data before storing them. And then, we have the algorithm and, again, notification bus for delivering notifications to the security controller. Basically, we worked a lot on the architecture, on the interfaces to build this kind of a concept. We didn't integrate a lot of different agents, but in any case, we integrated some interesting solutions like common bits from Elastic. We have a miner, which is a powerful detector, which uses different methods like time series and other tools for the detection of attacks. We use VDPI for bit packet inspection. We have a network scanner for finding vulnerabilities in the local subnetworks. We have a chip sector forwarder, which is able to inspect messages over a LoRaWAN network. And we also are exploring the usage of the eBPF programs to monitor data, which could be very useful in environments where we don't have access to the infrastructure itself, like serverless and PaaS environments, where we cannot deploy new agents at the kernel level. So this kind of agent is very useful to provide some sort of monitoring functionalities on demand. We are able to automate the configuration of a dedicated Kafka topic for the collection of information. And we are also able to enforce access control on Kafka to be sure that only authorized agent can push data to Kafka. This is a preventive measure to avoid fake agents or some kind of spoofing attacks to alter the decision process. We can, of course, activate and change the parameters of a few algorithms that we have available inside the consortium for demonstration purposes. The main objective for this project is not, as probably already underlined, it's not the development of new detection algorithm, rather the full platform as a tool that is able to integrate and to automate many preliminary processes for dynamic service chains. And of course, we have the possibility to run policies in the security controllers, which also takes care of configuring the full pipeline. What we don't support in this moment in this model is the possibility to configure Logstash for performing transformation and aggregation tasks both locally and in the centralized platform. Currently, there is only a simple indexing process in the centralized platform based on the topic name from which data are received. Another interesting aspect that we addressed in the project is the possibility to run security processes on behalf of a service provider. Okay, this is based on standard features like token-based authentication. We implemented this in Guard. Honestly, we have still to finish the integration in our use cases, but of course, we have the main things already implemented. And another interesting feature is the possibility to perform data protection by following the exchange of data in a data ecosystem, like, for example, the industrial data architecture. In this case, we improved the IDS connector, which is available for free. And we also built an application that is able to receive user preferences about sharing policies. So, for example, who is able to view the user data, who is able to transfer user data to external entities, and so on. The reference scenario is an e-health application where medical data must be shared by physicians in different departments. So basically, my time is almost expired, so I would quickly come to the conclusion. We are now close to the end of the project, which has affected the end of April. So basically, we already implemented the main platform. We are still finishing to integrate some things, and basically we have to finish the integration in two use cases. One is smart mobility, which is basically what I showed at the beginning of the presentation, and the other one is an e-health application where the main objective is to show how data can be safely shared and privacy respected within an hospital or a network of hospitals. And okay, one thing that I already said last year for what concerns standardization, our main interest is in the possibility to have an interface towards, let me say, security agents in general. For this, kind of interface. We needed to discover the name, owner, version, the available agent, the parameters, the data format, and so on. So to be able to correctly pipeline them to the processing algorithm. We used the REST API plus data models. We investigated the usage of standard interfaces, but they were not enough for our purposes. But I think I will come back to this topic this afternoon. And okay, finally, another topic of interest, already said last year, is the possibility to standardize this kind of architecture for a 5G network. But okay, this was already discussed, and I don't think it is worth discussing it again. Here are the main contact points for this project. The project coordinator, Mandisa from Majoli, myself, Matteo Repetto from CNR, and our communication manager, Angela Steyado from the Fireware Foundation. That's all from my side, and if you have any questions, I will be pleased to answer.
Thank you, Matteo. I don't think we have time for questions now. So thank you very much.
You're welcome.
Okay, let's open up our cameras as I asked you before. If you could also stop sharing, Matteo, so I will take a screenshot.
Yes.
Could you stop sharing your screen? Okay, thank you. So just 1 moment to take a screenshot for the guys that would like to open their cameras. Okay, nice. So, okay. Hello, Francisco.
So more cameras are opening up, so maybe take another.
Okay, 3, 2, 1, here we go. Okay, thank you guys. So we can move on to the presentation from Willy Victor from S-Secure for SAPPAN project.
Okay, so first, just to a little bit of organization. So first, thank you all, also the whole the project group for inviting us. So we're very glad to present our SAPPAN project. So today, this presentation will be given by me and 3 of my colleagues from the SAPPAN project. So, myself, Avikarsh Mandal from Fraunhofer, Martin from CESNET, and then Martin from Masaryk University, and Willy from F-Secure. So I'll just give a brief introduction from coordinator perspective about SAPPAN, and then we can go to the technical innovations from our project. Okay, so just a little bit of a brief introduction. So we are part of the same SU-ICT call from 2018, dynamic countering of cyber attack, like other projects here. So our project will run until April this year. And so some of our project highlights as like to support security operator or computer security incident response team for optimal incident response and find propose ways to recover from cyber attacks. So also we are looking at a platform, developing a platform for privacy preserving threat intelligence sharing among different organizations such as SMEs, and then we're looking at local and privacy preserving federated detection tools for effective response and recovery. And then another angle is also looking at visual and interactive support for SOC operators, and also for preparation, so improve the scalability of massive data and log processing for intrusion detection approaches, and finally optimal response recommendation and automation. So here is a brief overview of our consortium. So we have 8 partners and a good mix of commercial partners and academic partners. Fraunhofer Fit is a coordinator, and HP from Ireland, and F-Secure, CESNET, and DreamLab from Switzerland. They are our commercial partners, and we have academic partners, University of Stuttgart and Masaryk University and RWTH Aachen. So, so here is like how this data sharing approach in SAPPAN works. So we are looking at a typical incident response and recovery process life cycle, such as data processing, detection and assessment and handling. And there we're looking at the local level, and also like we are sharing the data and trying to perform the same actions in a collaborative level. And the privacy issues are handled before or during the data sharing process. Okay, and then so here are some few bullet points, like some like overview, like what we are looking at. So we are looking at scalable data processing, threat intelligence sharing, knowledge formalization for response and recovery action, federated threat detection and response, and efficient response and recovery actions. So today we will only look at 2 parts following my presentation from my colleagues. So we'll look at threat intelligence sharing and effective response and recovery actions. So here are the selected SAPPAN innovations. So today this talk will consist of first CESNET. Martin from CESNET will give a short talk on sharing how SAPPAN is doing the method for sharing cybersecurity playbooks. And then secondly, it will be from Masaryk University Mailer Analysis Automation Platform, from Martin from Masaryk University, and lastly from Willy from F-Secure will talk about collaborative data set creation for response recommendation. So yeah, so going to Martin.
Okay, thank you. So first, our motivation behind this activity was to formalize the steps in the form of the playbooks to enable automation of execution of these playbooks and being able to distribute them or share them with other organizations so we can leverage the steps, leverage the benefits of automating the response and recovery steps. So although the playbooks relates mostly to the response and recovery phase of the incident handling lifecycle, there is a possibility to utilize these playbooks during all the phases, such as during the preparation for the threat, for example. The playbook can describe how to deploy certain countermeasures to face the potential threat. And then the distribution of the playbook is important to establish, let's say, a communication channel, a mean how to hand over the playbooks to the end organizations, such as in the case of cybersecurity service providers, to spread the playbooks similarly to the way how other threat intelligence is spread. Also, sharing of the playbook can serve the community to share the knowledge how to deal with certain attacks, and sharing can enable, let's say, participation of multiple organizations in improving the playbooks. Next slide, please. Actually, the formalization of the playbook is a relatively young topic. Therefore, there are various formats, and besides other formats, also SAPPAN proposed one of its own. But let's say today the most relevant one is the collaborative automated course of action operations playbooks, and this is called, let's say, CACAO, an abbreviation of the long title. And we utilized CACAO as a, let's say, superset that can cover all other formats. And then we looked how we can utilize CACAO to enable sharing of the playbooks. And since Kakao is developed by Oasis, it is based on sticks concept. But we thought that sticks is not that often used among communities in EU. So therefore, we focused on a MISP sharing platform, and we proposed a MISP model to represent not only the Kakao playbooks, but also other playbooks. So the model captures the metadata and the playbook itself. This way, we can represent any playbook format, and at the same time, the shared object carries information that allows users to select relevant playbooks they are looking for. So basically, the metadata serve for, let's say, saying what the playbook actually contains in a uniform way, and the playbook itself is the original format of the playbook. So any format fits there. Next slide, please. So finally, we implemented the straightforward playbook sharing tool that can read the playbooks that are shared from MISP, and that can also store the playbooks into MISP. So on the figure, the playbook sharing tool is also connected to a translator that is able to translate the playbooks into workflows that are truly machine executable. And these workflows, after some customization to specific organizational infrastructure, automate the execution of the response and recovery steps. And so with this, I would like to hand over to my colleague who will further present such a workflow and its automation and being used for real incident handling.
Okay, thank you. I hope you can hear me well. I'm Martin Laštovička from Masaryk University, and I will present the malware analysis automation platform that we developed at the SAPPAN project. So next one, please. Thank you. So the main part of the presentation is the architecture of the automation platform, which is kind of complicated if you look at the picture. So I will talk you through it. And we start on the left side of the picture, where is a web UI, which is a simple web page to which the human analysts can upload a suspicious file. The primary motivation for this is to automate a quick overview or quick analysis of a malware that comes through phishing attacks. So you usually don't do a very thorough analysis of such files, but want to look at them quickly to distinguish malicious files and benign files. So when the analyst uploads the file to the web UI, the suspicious file is persistently stored into S3 data storage platform for further analysis. Then the Apache Airflow, which is the central point of the platform, comes into play, and it continuously monitors the S3 storage. And if any new file is detected, it starts the automated analysis process of the file. So the process starts by sending the file to the observable evaluator, which is a component developed by us, which takes the suspicious file and uploads it into Intel Owl platform, which is a very handy tool that integrates many third-party software or tools that provides analysis results of suspicious samples. And third-party tools that are connected into our demo prototype, you can see on the right side. It's VirusTotal, Hybrid Analysis, Alien Vault, Cloudflare, Google Safe Browsing, and MISP. So lots of platforms that I think all of you know, or you know many of them. So we upload the file into those platforms and gather results from them and pass them back to the observable evaluator. Now, why it's called observable evaluator is that it automatically gathers all the observables, which means the IP addresses or domain names with which the malware communicates, and then recursively evaluate each observable again through the IntelliWell platform with the connected third-party tools, so that we have data not only for the original file, but also for each observable that the malicious file communicated with. So with that analysis, we construct a final report about the file and pass it back to the Apache Airflow, which then uploads the analysis reports back to the human analyst to the web UI, so that he or she can look at it, and also uploads the results into MISP sharing platform for cooperating teams, so they can see there was some phishing attack with this malicious file as an attachment. The final step that the Apache Airflow does is uploading the malicious observables into blocking infrastructures, where we have prepared REST APIs so that we can block communications with the IP or domain, so that the compromised machines will not be able to contact the malware command and control centers. So that was the quick overview of the architecture. And now we can move forward and look at the deployment. We have implemented the platform so that it should be possible to deploy all the components with one command. So at first you need to provide your API keys to the third-party tools you want to use, because without your API keys, you will have only the free version of the tools, which is sometimes not so good as the paid version. So you choose which tools you want to use and provide the API keys into a configuration file, and then run the whole architecture using Docker, either through the native Docker Compose or using Vagrant with VirtualBox to set everything up. And with this one command, it is deployed. So now we can take a look at how the platform looks in the deployed state. In the initial state, the Apache Airflow is running and monitoring the S3 data platform for any new files. So that's not much happening there. But if the analysts on the next slide uploads a file to the malware analyzer, so that's just simple web page where we upload the files. Then the Apache Airflow starts the whole process. And we can see that the analysis starts the whole playbook for the malware analysis. This playbook is in the form of Apache Airflow directed acyclic graph, or DAG for short. So you can see all the steps that the Apache Airflow does. Those playbooks can be shared or improved for the needs of specific organizations, and the Airflow platforms is responsible for executing all the steps. So when the analysis is done, it's passed back into the web interface for the analyst to download and look at the file. So he or she can do just that, click download and view the report. And the report itself contains the information about the suspicious file. So next slide, please. Yeah, so here we can see the data collected from the third-party tools. It's basically a hash of the file and known variants of the file. So here we have some example of some Android Pegasus malware and all the known variants of it. And at the bottom of the page, you can see which tools marked this malicious sample as malicious and which mark it as harmless or that they don't know anything about it. So we have 3 tools saying the sample is malicious. So we can assume that this is indeed a malware, and look at the rest of the report, where we can see the observables gathered from those third-party tools. So on the next slide, we can see overview of the observables that the malware communicates with. We can see 4 IP addresses, and 3 of them are marked as malicious by Alien Vault, and the 4th one is not detected as malicious by any of the tools. So we can use this information to further investigate those malicious observables. For example, if any of our computers in the network communicated with those IP addresses, or we can let the airflow pass it into the mitigation platforms or mitigation tools that we have deployed. So on the next slide, we have the result. We have the same report uploaded in the MIST platform. So it's basically the same information you see in the PDF, but in the format of MIST, so now that it is shared. So and that was 2 times the same thing, the same IP addresses shared in the MIST format, which is basically the same. So we can just go through it and look at the mitigation I talked about, so that we have prepared a REST API that takes calls from the Apache Airflow and stores the result of the call. And if we have connected architecture at Maastricht University, we use remote triggered black hole technology, RTBH, for blocking on the backbone routers. And we have this response from the API that the 3 malicious APIs were blocked. So that's for the malware analysis platform. In summary, it is prepared to be deployed on any platform you want using one command in Docker. We have tested it on Linux servers and Windows machines. And the whole platform speeds up the initial evaluation of suspicious file and allows us to investigate the observables that are detected. And the main results is that it reduces the possible mistakes that humans can do, and the results are consistent across the analysts, and it doesn't matter if it's a junior or senior employee, their results are basically the same. So that's all from my side, and I pass the word further for the response documentation datasets. Thank you.
Right, so good morning or good afternoon, depending on where you are. So this part of the project dealt with assembling some data sets around response actions and possible recommenders for it. So these days, modern EDR products actually collect a hell of a lot of data from endpoints, and it offers us insight into what's happening on endpoint steering attacks that we've never had before. At the same time, we can also do things like remote investigations and real-time response actions that would previously require an on-site presence. Now, the thing is, handling advanced attacks, so more of the where live people would be involved, we need human detection and response teams. Now, and those are specialist skills that's pretty hard to acquire on the market in general at the moment. So scalability in terms of that will remain a challenge. Which is the reason why it would be really beneficial to start adding some automation, or at the very least some assistive technologies to aid people like responders and threat hunters and so on. When it comes to automation, like at least quite a bit of progress has been made in the space of attack detection and so on through data science. So all of these masses of data that I referred to earlier, to actually mine those to pick up things that we wouldn't pick up using pure rule-based sort of approaches. But unfortunately, at this point, investigating incidents deeper, especially when it's more advanced attack, and actually responding to them remains a largely manual process. Slide, please. Right. So when it comes to incident response actions and so on, the workflows are generally pretty well recorded in things like logs and so on. And I mean, the most important reason for that is when you start taking action to respond to incidents, a lot of those can be quite invasive, and you can very easily cause downtime or damage or so on. So those things need to be recorded so they may be revisited afterwards. And at the same time, also, it's pretty good for training teams when an incident happens to maybe go back, review it a bit, and along with it, things like the detection data, and have a look at the decisions that a responder made. Yeah, that's pretty important. Now, actions that responders take can usually be linked to elements of an incident, but at a very high level. So it might be to say, yes, we went and issued a job across 10,000 endpoints to delete a list of files with certain hashes. So that's at a high level that, yes, something was identified that was malicious, and we issued this sort of job. Where the problem comes in is if we are looking at things like, yes, a certain action X was taken, and that was directly connected to like detections, observations, outcomes from threat hunting, these specific ones, A, B, and C. This process with these characteristics that was detected along with these sort of IPs, these 3 or so events was directly related to this action that we took. So that fine-grained causal relationships where you see these observations caused this action to be taken. And the thing is to actually build effective sort of recommendation systems and assistive systems, maybe even get to automated response actions during incidents. We actually need that action cause kind of thing to be pretty strong, so we can have a high degree of confidence in the models. Slide, please. Yeah, so we investigated how we would actually put these data sets together and harvest them and so on. And for various elements of it, there is actually quite a bit of standardization already. So if you want to describe the various techniques that attackers might use, as long as some of the defensive measures that defenders can put in place, it's a long-running project that's pretty good for that, and that's around MITRE, things like MITRE defense and MITRE attack. When it comes to documenting incidents, things like IOCs and observations, and actually like some limited actions at least in a machine readable format, there's sticks for that. And as was discussed, when it comes to documenting response workflows, so that would be to say, if we see this, we do that. If it reaches a certain point, we need to do that, and so on. And some of the automation orchestration. Yeah, Cacao contains a lot of it. But in our research, we couldn't actually find something where response, like there's maybe a taxonomy along with a specification for like how to record specific response actions and their causes. So so we investigated well, first of all, the feasibility of building these action response data sets to have as training data sets, and also like how we would actually represent that. And basically realized that that's actually like some essential work that would need to be done first before we'd be able to proceed with that. Next slide, please. Right. So if we look at what would be contained in the data, sorry.
Yeah. So sorry to interrupt you. I would like to ask you to wrap up as we are out of schedule.
This is the last slide. So.
Okay.
This is
that's great. Sorry.
Okay, I'll be quick on it. So there's when we look at detections, observations, and the sort of actions that need to be taken, I mean, those are listed there, and a lot of those are already covered using existing standards. So what we would actually need at this point is to say, oh, well, let's go and define a structure within which we can actually capture all of these data points and have it in a suitable way where it can be used as sort of machine learning data sets. Now, we would like to use that existing standards, but also need to be product independent, because we probably can't source sufficient data from just a single or one or two vendors. So it needs to be portable, and it would need to be integrated into existing tech stacks in some way, because data collection of this kind would probably need at least a high degree of automation in that process. And that is all from me. So sorry for overrunning a bit.
No problem. Thank you very much for your presentation.
Yeah, so that's it from SAPPAN side. So if you have any questions, you can feel free to contact us. And this is also our website. I just put it in the chat. So just in case. Yeah.
Thank you, Avi. Yeah. So the next project in line is SIMARGL. I don't know if.
Yes.
Okay.
Yes, I'm here.
Hello.
Okay.
Marek. So.
Hello. Just give me a second. I'll share the screen. Okay. Okay, you should be able to see everything. Okay,
Yes.
so
we can see it. I would like to ask you to try to be as short as possible. Sorry for that.
So hello. Hello and welcome. This is Marek Pawlicki from ITTI, and I will have the pleasure to present to you some key points about the SIMARGL project, which hopefully you will find interesting. Now, most of us here are from the security background, so to keep things enjoyable, I'll spare you the typical introduction and motivation part and only focus on the specific angle that makes the SIMARGL project special. So just to give you the gist of things, SIMARGL stands for Secure Intelligent Methods for Advanced Recognition of Malware and Stegomalware. And as such, we're developing methods to counter attacks coming from a wide range of vectors, something I will explore a bit more in this presentation in just a minute when we get to the toolkit. But also we have this strong focus on detecting steganography. And if you don't yet know what steganography, hidden information channels, or stegomalwares are, then I hope I have sparked your interest and you're going to listen very closely for the next 15 minutes or so. Now, our project started in May 2019, and it's a 3-year project, so we're currently pushing the final effort to provide as much value as we can in the duration of the project, as it ends with April. Now, if you're like me, you like to know who are the people doing the work just as much as what the actual work is. So we are a consortium of 14 partners based in 7 countries across Europe. Now, we like to point out that it is a well-balanced consortium of researchers and institutions SMEs, end users, and SSH partners. But that is not just me tooting my own horn, so to speak. That's not just based on a subjective feeling. We now have some results that flow directly from the way the consortium is constructed, and I will talk about this more later in this presentation. But I promise not to do too long of an introduction, so let me just get to the meat of things. So allow me to introduce to you the SIMARGL toolkit. Now, as you can see, I have covered most of this figure, and that is there for a reason. We'll get back to this figure after some more slides. But right now, I just give you some initial structure so you have a feeling that you know where you are. So this is more or less the structure of the big chunk of the presentation, and I want to show you that it mirrors the way the SIMARGL toolkit structure is formulated. Now, what you have in front of you is a very general overview of the attack surface coverage of this toolkit. In principle, we have three very broad, very general types of events. I think most of us are familiar with MITRE ATT&CK framework, so these three categories more or less have a mapping to the data sources in the MITRE ATT&CK catalog. So as you can see, we have network events, web events, and file events. Just bear this in mind because I'm going to go back into specific. Now I'm going to go into specific examples of the use of specific inventory items of the toolkit and build this figure from the ground up. Now, let me slowly introduce one of the solutions we've developed in the project. I'll get more into the details on the next slide, but this is a good place to start. So one of the solutions is what we call the big data engine. It's a machine learning based network intrusion detection component. What you see now on the slide is one of the earlier research pieces we've produced. Basically, we took one of the then recent benchmark data sets. It was not ideal for our purposes, but good enough for the early stages. Did a couple of experiments with different classifiers, different feature sets, different hyperparameter setups, etc., etc. Nothing too fancy, but got the job done. And we tinkered with it until we got some relatively good results, and this paved the way to what we have on the next slide. So now in SIMARGL, we have had this incredible opportunity to work with some amazing, well-versed use case partners. An example of such joint research endeavor is now on the slide. Now, there's a lot of things to unpack here, so let me just go step by step. Now, let's just focus on the colorful flowchart in the middle of the slide for a second. This is basically where the rubber hits the road. So the big data engine is a machine learning-based network intrusion detection component, and we detect intrusions on the basis of net flows. As you well know, net flows are aggregations of traffic data, very useful for traffic analysis. So we've gone and did some research and found out what features can we extract from net flow, what would be the most informative from the network intrusion detection standpoint. But to get this to work in the wild, you actually need to collect net flows in the end user network and get them to the machine learning component. So what we do is we set up our probes into network and send net flows to Apache Kafka. Now, Apache Kafka is an open source distributed event streaming platform that I'm pretty sure everyone here is probably familiar with. So let me go directly to the next step, which is the big data engine. Now, BDE is this neat little magic box that is written in such a way that it allows us to achieve scalability using Scala when we need it, or it allows us to employ all the fancy machine learning packages we all know and love, like scikit and TensorFlow. So basically, whatever awesome new TensorFlow algorithm pops up, we can plug it here and send the results of the detection either back to a separate topic on Kafka or index it in Elasticsearch to produce a dashboard in Kibana. Now, you can see on the schema in the top right where in the network the net flows are collected and then sent to the BDA platform. Thanks to the cooperation with reunited, a Romanian educational and research network. The SIMARGL project was able to publish a real, recent, open, NetFlow-based labeled dataset collected on the reunited premises. So the most important aspects facilitating the successful deployment of our machine learning-based network intrusion detection system in the reunited infrastructure are shared with the research community. The dataset was collected and published last year, and you have the breakdown of the feature importances right now on the screen, and you can download it for free from Kaggle, either by going to this link or just by Googling SIMARGL dataset. Now, in SIMARGL, we also have one of the world's leading telecommunication solution providers, Orange. Thanks to the Polish Orange Search, we have gained access to a large amount of real network data. This is another use case for the big data engine network intrusion. The data format we worked with were based on IPFix, so in addition to informative features such as source and destination addresses or ports, the features also presented values such as the number of bytes or packets transmitted in a given frame, divided into incoming and outgoing traffic. The structure of the Orange network is shown on the picture. That is the so-called TP-net. This is our Orange Poland backbone network. It basically consists of numerous routers and has several entry points, which are called upstream links. The total aggregated capacity of the sublinks is measured in the terabit scale. Now, the results of this joint endeavor, along with a detailed description, were published last year on RS. Now, the BDE platform is one of the solutions in the SIMARGL toolkit that facilitates security against network intrusions. Now, as you can see, this is just one of the solutions. I don't want to get too much in depth into all of those, but we aim to protect different aspects of the network with different solutions, including, for example, the HoneyNet, which is a system that is designed to simulate a subnetwork of an existing information system in order to deploy honeypots, and of course, to lure attackers to help identify their tools, their tactics, and basically what they are looking for. We also have the extended Berkeley packet filter, so that's the eBPF filter. It allows to collect information on the behavior of a host, like, for example, system calls, as well as on the network traffic, so statistical information with, let's say, per packet granularity. Within the SIMARGL toolkit, this tool is used to produce condensed indicators that can drive or ease the detection of network coverage channels. More on covered channels in just a moment. Now, in the toolkit, we also have tools for monitoring and protecting web services, designed to ensure the security of critical web applications with a tool named Web Application Security, or for safe internet browsing with a tool named Internet Security. It deals with preventing and detecting several topologies of cyber attacks, such as malware, phishing, or scam. Or finally, we have tools like the Orion malware, which is a file analysis solution provided by Airbus Cybersecurity. The solution combines several analyzers, static analysis, dynamic analysis, heuristic, things based on artificial intelligence. The features of the tools are that it combines 5 antiviruses for instant detection of already known malware, and allows for detonation in a sovereign sandbox with anti-evasion system. So it has undetectable hooking for the advanced or unknown malware. It also allows us to have a whitelist for instant detection of certified clean files. Has an advanced static analysis scanner function based on heuristics and machine learning models, and features a scripting language identification function based on deep learning analysis engine based on user detonation rules. And in the most right corner, we have Mavis. This is the dedicated software for the detection of the least significant byte steganography, which was made with the use of invoke PS image. More on this on the next slide. So this is a very content-heavy slide, so let me unpack it bit by bit. So first of all, steganography is the practice of hiding a secret message in something that is not secret at all. For example, changing the least significant bytes of an image file to conceal a message. This is where invoke PS image comes in. Invoke PS image is a piece of software that takes a PowerShell script and embeds it in the bytes of the script in the pixels of a PNG image. So basically, it generates a one-liner for executing either from a file or from the web. So, for example, it can embed PowerShell code from the invoke mimikatz module and embed it into an image file. And by calling the image from a macro, for example, the macro will download the picture and execute the PowerShell code, which in this case will dump all the passwords. This is, by the way, a direct quote from Might Attack and from a 2017 paper by Adams. The example that is on this slide comes from the Your Sniff campaign in Italy. The campaign used steganography to propagate the Your Sniff Trojan. In fact, this Super Mario image contains a hidden malicious payload. So in SIMARGL, we have developed a tool capable of the detection of steganographically modified digital image files and the extraction of the malicious script. This use case that is found now on the slide is also a use case that involves Orange. Now, to wrap up the toolkit, we also have an informative dashboard, naturally, that collects all the outputs from the deployed tools and allows the user to keep tabs on what is happening. A lot of the things you have seen in this presentation so far have found their way into scientific dissemination. In the duration of the project, we have published over 40 papers, including a large-scale survey of malware threats and trends in detection, which was published in IEEE Access. Papers on detecting stegomalware and covert channels, papers on machine learning-based network intrusion detection, naturally optimization of neural networks for network intrusion detection, things like real-time stream processing, use case papers of science used in the wild, so let's say close to the market. But SIMARGL is much more than just technical contributions. In scientific dissemination, we also have papers describing cyberspace actors, for example, on a guideline for achieving GDPR compliance for malware detection tools. But SIMARGL also produces training materials. In fact, we have a training program that anyone can enroll with topics covering cyber threats, cyber attacks management, cyber threat intelligence, and many more. And with the backing of Fernuni in Hagen, the SIMARGL cybersecurity training courses can gain anyone AQTS credits. There are over 50 hours of training available, and up to this point, over 230 people have enrolled. And we're also providing training for law enforcement and for Europol, sharing crucial information bits, things we call cyber bits, about cybersecurity, about information hiding, about malware and other topics covered by. And one last thing before I wrap up, let me invite you to one of the SIMARGL-related special sessions we're still planning to hold. There's still time to submit papers, so if you feel you like what you have seen here and you'd like to keep in touch, we're gonna be there. So the first one is SecSoft, and then we have the detonator session on the European Interdisciplinary Cybersecurity Conference, and then queuing on ARES. And that's all I have for today. So if you have any questions, comments, or suggestions, I'm open.
Thank you, Marek. It was a really interesting presentation and a lot of information. Please post the training link and the link to the project in the chat so we can access it. I think we're going to find a lot of useful material there. Okay, let's move on to the next presentation from SOCCRATES project. I think Reindeer is here with us. Hello.
Yes, I am. Yeah.
Great.
Can you see the slides?
Yes, yes. Thank you very much.
Okay. So I realize that I'm standing between most of you and lunch. I know that I'm standing between me and my lunch, so I will keep it short. So I want to share with you the SOCCRATES project and results. SOCCRATES is one of the projects in this call, of course, and the vision of SOCCRATES is that we develop a platform to automate security in SOC CSIRT environments, specifically for real SOCs at big companies and MSSP SOCs. And the idea is that we do not want to take away all the tasks an analyst and an operator does now, but we want to support the analysts in the SOC and CSIRT to enhance their situational awareness and their option awareness. So hence the little robot here. So we want to support the analysts so the analysts can function on a higher aggregation level and take decisions based on information provided by the automation platform. The basis of SOCCRATES is 5 use cases. So use case 1 is the response on detection of an ongoing attack. So this is the normal detection, but we also have 4 other use cases which are more proactive. So if we receive new cyber threat intelligence, our use case 2, then we look if they relate to the infrastructure that we monitor. But also we have use case the response on discovery of new vulnerable assets if you do monitoring of vulnerabilities in your infrastructure. And we also look at if there are system configurations of new systems deployed in the infrastructure. Then we also look at whether this introduces new threats. So the general flow of our use cases is, like I said, we want to increase the situational awareness on the one hand, and this is how we do that is by collecting and enriching security event information. And with that information, we perform an attack defense graph based threat analysis. So in the model we built of the infrastructure, we look at attack path with the ADG component. And at the same time, we determine potential business impact. So what we also do is build models of the business processes of the company that is monitored and try to find out whether a specific attack that we simulate with the ADG that we find could have impact on the infrastructure, what kind of business impact is there. And we create the option awareness, so in the mitigation response planning phases by collecting and generating courses of action, but also assess the effectiveness of those courses of action by also looking in our models in the ADG analyzer, whether it actually solves the vulnerability or the security incident. And we also assess business trade-offs of the course of action. So in the end, what the operator will be presented is a list of course of actions, which also have the implications. For example, what does it cost in time to deploy this in the infrastructure, but also what will be the business impact if we actually deploy this specific course of action. And we generate playbooks for the course of action that we present. And part of those course of action also will be played automatically and be deployed in the infrastructure automatically. So we built this platform to implement this this flow, where we have a central orchestration and integration engine, which is based on activity and I forgot the other activity, and there was another component in there. where we have a workflow component and an interface component, and the interface component actually interfaces with the modules we have built around the central orchestration integration engine, where you can see that we have infrastructure modeling, which automatically builds a model of the infrastructure. We have the AI-based attack detection module, which actually deploys several types of sensors, and then with a reasons engine collects all the outputs of the sensors to provide a better picture. With the infrastructure modeling, we can do the attack defense graph analysis, which also builds and assesses the course of actions which are generated. We also build models of the business logic, and we can do business impact analysis with the business impact analysis, where we also use to assess the responses of the course of action. So we have a response planner. And at the same time, our partner Shadow Server collects a lot of threat data, and we have a threat intelligence platform where this is being fed into, and we can then see whether new threat intelligence actually causes new vulnerabilities to appear. And we connect with existing SIEM solutions which are in SOC C-Search, and we have a web front end. So this is the platform we actually built. And all those components are Dockerized. We have a total of 50 Docker containers here managed by Portainer, which makes it easily to deploy. And we are actually almost ready to start our main pilot. We already had a technical pilot where we tested and evaluated a few of the technical components. In a few weeks' time, we have a little bit of delay because of the COVID situation, which prevented us to come really on location to help deployment. But in a few weeks' time, we will start the main pilot, and the main pilot will actually be on 2 locations: the corporate IT SOC of Vattenfall in Poland, and we have an MSSP SOC of Mnemonic in Norway. And also a role in the pilot will be from Shadow Server, which actually collects and shares data, cyber threat intelligence information through their extensive monitoring of the internet each day. What we will do on this pilot, it will last for 4 months. We will evaluate this with KPIs we have defined beforehand. I'll come back to that in the next slide. And after the pilot has ended, we will build a demonstrator environment, which actually will run mostly on TNO cloud research infrastructure, but also Shadow Server is involved, and part will be running at F-Secure, where we can show, because the pilot will of course involve customer data, which is privacy sensitive, which cannot be shared. But with our demonstrator, which we'll use at the end of the project to demonstrate the actual platform and its functions, we will use dummy data so we can really show how things work and how effective the platform is. So I will not go through this list, but we have defined already in the proposal a number of KPIs where we try to measure the impact of the SOCCRATES platform. So to take one, successfully reduce the total time of detection and response. So we have a set a KPI that it will reduce the total time for detection and response for use case 1 to 50%. So we try to, in the pilot, evaluate those kind of KPIs. Other KPIs that we are evaluating is on the cyber threat intelligence, where we detect new unknown malware by the DJ detector. And beside the real hard KPIs that we evaluate, we also have some supplementary pilot metrics where we look at the platform activity and performance. So we monitor how the performance of the SOCCRATES platform is during the pilot, and this will be done mostly automatically. And the other thing we look at is the analyst experience and perception. Of course, the human-machine interface also is very important in here. So how does the operator actually experience the use of the SOCCRATES platform? And we will do this by weekly evaluation forms and also have interviews with the analysts. So hopefully this will provide us with a lot of interesting evaluation results, which we can use to have improvement suggestions for our SOCCRATES platform. Well, we are almost there. So we are now in the final half year of the project. We are discussing with our PO, which I actually speak this afternoon, that we might extend the project with 2 months because we have so much to do that we need some more time. So we are actually at the second pilot, which is our main pilot, about to start. And then we have the demo pilot, and we'll organize a final SOCCRATES workshop, probably in September somewhere, where we also show the demonstration environment, and we will show all the results of the project. Well, we also are involved in standardization activities. So we adopted OpenC2 and Cacao, which already was mentioned a few times in previous presentations from OASIS. Also contacted the OpenC2 technical committee because we have some specific OpenC2 command questions. As TNO, we became a member of OASIS Open, so we can also represent SOCCRATES there. And also we have had some contributions to the MITRE ATT&CK framework from our partner Mnemonic, who did work on adversary emulation planning. And this actually resulted in a contribution to MITRE ATT&CK, which is now mentioned, where SOCCRATES also is mentioned as a contributor. What we still plan is identify missing commands in OpenC2 and also bring this into the discussion at the technical committee of OpenC2, and also identify lessons learned by implementing Cacao in the SOCCRATES environment, and also bring this into the TC of Cacao. Of course, we are looking into exploitation towards the end of the project. How can we actually ensure that the SOCCRATES results will actually be exploited? Well, part of the exploitation will be done by individual SOCCRATES partners. So we have the more vendor-like partners, F-Secure, Forseti, and Atos, which will include some of the SOCCRATES solutions into their products. But we also have some joint exploitation efforts. So we will ensure that the SOCCRATES platform can be rebuilt by anyone who likes that. So on the SOCCRATES website, in the end of the project, we will have a manual available with links to all the software that is required, which is partly open source, but there are also some commercial licenses needed. And we are considering maybe also to make available separate functioning units of this platform. So it's not necessary to build the whole platform, but this is the way we want to ensure that the platform will live on after the project ends. We also have some community contribution, of course, in the standardization effort, which I already mentioned in the previous slide. And also we already have some open source publications, which can be found on our website, for example, on the DGA detective and the adversary emulation planner. And we are expecting that this will grow in the coming months. And I wanted to point out that we have actually a webinar next week on the responding to ongoing attacks. There's actually we're going into quite elaborate detail on how the platform will handle our use case one. So I can really recommend this webinar, and you can find more information, sign up also on the SOCCRATES website. And actually, this is what I wanted to shortly present. Of course, if there are any questions, you can always contact me or Frank Fransen, my colleague, who is a technical coordinator. And I think then I have not consumed so much time, so we can effectively go to lunch if there are not questions at this moment.
So first of all, thank you for the very informative presentation. You have done a lot of work. Kudos to you. You can also, of course, paste the link for the webinar to the chat. So
yeah, I will do that. Yeah.
So if you were to pinpoint just, let's say, one major contribution from Socrates to the existing SOC technologies, what would that be?
Yeah, I think it will be the connection between technical and business processes. So what we do is not look only at the technical infrastructure, but what we do is try to find out how the infrastructure is targeted by attacks, or what will be the impact, the technical impact, but we also try to connect this to the business impact. So if you have a course of action, then you not only look at what kind of impact will this course of action have on the technical infrastructure, but we also at the same time provide the analyst with a view on what kind of business impact he or she can expect when implementing this course of action. And I think this is quite new, that you automate this connection between infrastructure, technical infrastructure, and business. And if you ask one thing, I think that's an interesting thing I like from Socrates. I mean, there are a lot of innovations and good thoughts, of course, put into the platform and the modules, but I really like this integrated approach.
Yes, exactly. Because this can also be presented, let's say, to the CEO levels and understand the importance of.
So you don't have to be a technical trained person to understand what the impact will be. And that's also what we say about SOC analysts who will have to work on a different level, but it will be easier to share potential consequences of course of action with guys on C level, for example, who have to take maybe the decision.
Okay, thank you very much. I don't see any other questions, so I think we can break now for lunch, and we will be back at 13:30 for a presentation from Concordia project. So thank you very much. See you in about 40 minutes.
Okay.
Okay. I hope you had some time to get lunch, had some rest, so we can go on to the next part of our workshop with the invited talks and more presentations on cybersecurity standards. The first talk of the afternoon session, let's say, is from Concordia project about the project key exploitation results, and the first speaker is going to be Aliosa Pasik from Atos. So I see you have already shared your screen. Aliosa, I cannot hear you.
Okay, now let me know if you can see. I will try to see if to put it in a full mode.
Yeah.
If you do you see? Yeah, it's working. Okay. Okay, thank you, Manos. So I will give a presentation which is basically introduction into something which is more, I think, more interesting. It will be more interesting. So hopefully, so. In Concordia is one of the 4 pilot projects for establishing European cybersecurity community. As you probably know, there are we have ongoing initiatives in Europe for establishing European Cybersecurity Competence Center, which is based in Bucharest, which is a central node, and then we have a network of national nodes at the second layer in each member state. There will be a kind of node for this competence center. And then we have a cybersecurity competence community, which is piloted in 4 projects. Concordia is one of these 4 projects, and I will talk about exploitation. We are now in the final year, entering the 4th year. So we already have experience from the previous 3 years. In each year, we did kind of collection of exploitation results and then filtering, and I will explain how we do it. So the idea of exploitation in Concordia is to keep up with the market. Of course, we want also to link to policy and strategic needs of Europe. So it's not only about the market watch and market analysis that all European projects are trying to do, but also linking to what should be a strategic research agenda linked to European industry and also road mapping activities. And finally, the ecosystem approach, which is very important. You will see in my next slide that we in Concordia, we want really to link exploitation to this ecosystem approach. So if an asset, let me just see, okay, so if an asset can be exploited individually, so there is no need for ecosystem support for sustainability or for reducing the cost, then in our ranking, this asset, even if it's very good exploitable results, it will score less, because we have this criteria, which is called ecosystem criteria, in which we give higher score to these exploitable results that rely on ecosystem. It could be, you know, because of the economy of scale. It could be because of the partnerships for the exploitation, whatever, but we are also introducing this criteria in the ranking of exploitable results. Then I already mentioned top-down and bottom-up alignment. We have a kind of a board, which is Industrial Strategy Committee, so it's Innovation Exploitation Board, which is only composed of industrial representatives. So we in Concordia, we have 54 partners, I think, and at least 27 are industry, so it's quite significant European cybersecurity industry representation. It's not that every time everyone is attending, but a lot of these persons who are in this committee, they act as a referee in this ranking. And then we use different methodologies depending on the issue. So this is this process. We have 4 criteria, and this is what comes in and what comes out. What comes out is list of key exploitable results. We had in the first year, we had 28 exploitable results. Then we had moved to 30 exploitable results. We have different stages of maturity and beginning of the projects, end of the projects, and different industries that are involved in pilots, because we have also 5 different pilots in Concordia. Ranking, as I said, is a kind of highlight of this process, because it's normally done in December, end of the year, and then the exploitable results are ranked to 4 criteria, and then we try to come up with key exploitable results. And one of these key exploitable results is DDoS clearinghouse, which will be presented in the continuation by my colleagues from SIDN. We are giving, let's say, we have to focus on or give priority in dissemination in exploitation activities to these key exploitable results, because otherwise it would be impossible to with the resources that we have. And final slide is about transition, research to market transition, and what do we think about how this cybersecurity community, competence community should work in the future. And I think very important is to align objectives and incentives. We have a problem sometimes with incentives of some stakeholders. So these incentives have to go beyond EU funds, because many, especially end users, are not incentivized only if they receive EU funds. So we are missing in the community, we are missing demand side players, we are missing large companies that are users for cybersecurity, and then to want to act as a first deployment in kind of proof of value sprints that are that should be also included in the future community. And finally, also economics of cybersecurity. We have also activities related to, for example, how to optimize investment, where to invest inside of cybersecurity, in which phase is preventive versus reactive versus, and then also to reduce costs by using this ecosystem approach, which I mentioned previously, for example, using testing labs to prepare for certification, or to use skills and shared resources. So with this, I will pass the word to my colleague from SIDN, Thijs. I hope you're connected.
And just before moving forward, yes. It was a
yes.
really interesting presentation. Have you published this new way of calculating the key exploitable results? Do you follow a standard, or do you consider make it more formal that can be used from other projects as well?
Yeah, no, not really. No, we have focus groups between 4 pilot projects. These 4 pilot projects are ECO Cybersecurity for Europe, Sparta, and Concordia. We spoke with some colleagues about the formalization of this approach, but it's not standard, definitely. And what we had in the last meeting of Industrial Strategy Committee, we had idea to come up with kind of market readiness level, which is already there are some scales that exist and that are comparable to technology readiness level. And we want to combine this to something, to come up with something which is called exploitability readiness level. I know it sounds like a Frankenstein, but it could be a combination of these factors that I mentioned. So the market readiness, desirability, strategic importance for Europe, policy alignment, and all these issues. But it's only draft idea, and we have to work it out.
Okay. Thank you very much.
Thank you. Okay, Thijs, unless there are other questions, I will pass. Any other questions?
That sounds good.
Okay, so I will stop sharing my screen just a moment. Okay, so.
All right, let's see. Oh, hold on. Can you all see this presentation?
Yes.
Great. Okay. Thank you very much for the introduction. My name is Thijs van den Hout. I'm a research engineer at SIDN, which is the registry of .nl. That's the top level domain in the Netherlands. And we participate in the Concordia project. And in particular, we're tasked with the development of a DDoS clearinghouse for Europe. The concept of the DDoS clearinghouse is what I'll explain in this video or in this presentation. Then I'll go into the testbed that we've developed for the clearinghouse, and I will end with a demonstration video of the clearinghouse in action on that testbed that we've developed for it. So given the nature of this event, I'm sure you're all aware of DDoS attacks, all familiar with the term DDoS attack. And even though there are many established DDoS mitigation services out there, we still see high impact DDoS attacks all over the place. These are some recent examples of high impact DDoS attacks. They often target important infrastructures like banks and government services like online identification platforms. So we can say that DDoS definitely remains relevant despite these existing mitigation services. And one of the problems that we've identified is that indeed, as I mentioned, there exist mature DDoS mitigation services like scrubbing services that routinely handle big DDoS attacks. But there is no sharing of DDoS data and expertise between organizations. And this means that each organization is limited to their own narrow view of the DDoS attack landscape. And they can ward off attacks with their own mitigation strategies or using a hired server for this, but they don't share expertise or data with others. And this reduces innovation of these mitigation strategies and of the resilient systems at an ecosystem level. because the data is stuck in DDoS mitigation systems. So by having everyone do their own thing, the probability of societal disruptions through online services increases. Our solution is called the DDoS Clearinghouse, which is a more collaborative and proactive approach to tackling DDoS attacks. An important piece of context is the concept of an anti-DDoS coalition. This is a coalition of organizations that have agreed to collaboratively combat DDoS attacks by sharing experiences and data and by doing large DDoS drills. And the DDoS Clearinghouse is a system that fits in such a coalition, and it enables the sharing of the DDoS data in the form of DDoS fingerprints. A fingerprint is kind of a summary of a DDoS attack that contains information like the source IP addresses, the protocols, ports, the duration, the types of attack, and that kind of information. And by sharing this information between organizations, they can obtain an ecosystem-wide view of the DDoS attacks that occur in their sector, for example. Importantly, the DDoS Clearinghouse is a system that extends DDoS protection services and does not replace the existing ones. The DDoS Clearinghouse is a use-inspired research between the Concordia project on one hand and the Dutch Anti-DDoS Coalition on the other hand. So the research and development of the Clearinghouse happens in Concordia, where we also built a testbed. I'll go into more detail about that later. And for Concordia, we will evaluate the system through pilots, which we plan to do in the Netherlands and in Italy. And we will deliver a DDoS Clearinghouse cookbook, which includes the technical components of the software of the Clearinghouse, but also all our lessons learned during the pilots and the operational and legal side of things. And this cookbook can then be used as a basis for other anti-DDoS coalitions to form and set up their own DDoS Clearinghouse. On the other hand, the Dutch Anti-DDoS Coalition is an existing group of, I believe it's 17 organizations from different sectors in the Netherlands, like ISPs, but IXPs, telecom, and government agencies. And they share DDoS experience and perform DDoS drills, and they will run the DDoS Clearinghouse operations in production after the Concordia project ends. So it's developed on one hand in Concordia for use in anti-DDoS coalitions, like the existing Dutch coalition. Now, how does the Clearinghouse work? Let's say these are organizations in an anti-DDoS coalition, and one of them receives a DDoS attack on the left here. And this organization saves the DDoS network traffic in capture files like PCAPs or NetFlow files, which can be analyzed by the first core component of the Clearinghouse, which is the dissector. So the dissector takes as input the network capture file, it analyzes the DDoS data and summarizes it into a DDoS fingerprint. And this fingerprint is then uploaded to the DDoS DB, which is the second core component in the Clearinghouse. This is a database that is shared between all members of the anti-DDoS coalition, and it's used to store and share these DDoS fingerprints with members in the coalition. And other members of this coalition can then download these fingerprints and use them to increase their readiness for DDoS attacks. For example, by using the converter module to generate mitigation rules from a fingerprint that they can install on their firewalls. And this way, the other coalition members are better prepared when that same DDoS attack is targeted at them. And this is a more collaborative and proactive approach than the existing solistic and more often than not reactive solutions. Well, this is an example of such a DDoS fingerprint. It's a JSON file that includes information about the attack. And at the bottom, you can see some summary statistics of the entire attack, like the average bits per second, the duration, and the type of attack it is. But the fingerprint also contains an array with attack vectors that make up the attack. So each of these attack vectors describe one part of the attack. And in this case, it was just a single vector attack, namely a TCP ACK flood. And the attack vectors, they include more information about that vector, like IP addresses and the ports that are targeted. So what are the innovations of this project? One is that we bridge the multidisciplinary gap between the development of such a technical system to deployment, which is a lot more than tech. The organizational and legal side of things should not be underestimated. Things like data sharing agreements and integration into production systems are required. It's a completely open source design, which we will publish through a cookbook that I mentioned. So the clearinghouse components, all the software is open source, but we will also publish the organizational lessons learned to enable others to set up their own coalitions. And lastly, the system operates across heterogeneous networks and offers a rich set of services. So organizations use different infrastructures and they have different needs within a coalition. So the clearinghouse should be flexible enough to accommodate this. For example, the dissector can work with different types of network captures to generate a fingerprint. This is the Dutch Anti-DDoS Coalition. As I mentioned, it consists of organizations in telecom, internet business, and government agencies. But we also have a member in the world of DDoS mitigation, namely NBIP. NBIP is a Dutch scrubbing service, and they will operate the DDoS clearinghouse in production in this coalition. Currently, the pilot infrastructure is hosted by us at SIDN. Now, our recent key achievements, both in Concordia and in the Dutch Anti-DDoS Coalition, they are the following. So we have developed the clearinghouse to the point that we have a stable prototype, which is ready to be used in a pilot. With that, we've completed all the technical preparations for the pilots. We've also developed a test bed on which we can test the clearinghouse, which I'll talk about in a minute. And we were selected for the European Commission's Innovation Radar, which is great. And on the Dutch Anti-DDoS Coalition side, they have received additional funding from the Dutch national government for the DDoS clearinghouse deployment and operations after Concordia. With that, they will hire a product owner or a product manager to oversee this process. And they've also recently agreed on and signed a consortium agreement. So the DDoS clearinghouse will definitely live on after Concordia. This is the timeline of the project on its way to production. We were anticipating the pilots in the anti-DDoS coalitions to happen earlier, but the organizational and legal tracks have caused a delay. So as a precursor to the actual pilots, we set up a test bed. And on this test bed, we can pilot the system in a non-production setting. And we're slowly moving away now from the pilots on the test bed and into the pilots with the members of the Dutch Anti-DDoS Coalition. And this year, we also plan to go into production where NBIP, so that one of the members in the coalition will host the infrastructure. Now, I've mentioned the test bed a couple of times, so let's get into that. As I said, the goal for our project in Concordia is to deliver a prototype DDoS clearinghouse and to pilot the system in 2 coalitions, so the Dutch Anti-DDoS Coalition and one in Italy. However, we've experienced some obstacles in this process. Firstly, the organizations are hesitant to deploy software that is still in development on their production systems, probably rightfully so. But we do want to pilot this system in their production systems as it will be deployed after development. Another obstacle is the legal agreements, like the data sharing agreements that are required between the coalition members. And that is because the fingerprint contains personally identifiable information, namely the source IP addresses of the attack. So as an intermediate step, we set up a test bed on which we can pilot the technical components of the DDoS clearinghouse in a representative environment without the obstacles that I mentioned before. And our solution to the problem of production systems is that we deploy the clearinghouse at the members of the Concordia project, and these members have systems dedicated to research, so not in a production environment. So if we do break something, it's not detrimental to the business. And to tackle the legal agreements, we will work with simulated DDoS data, so synthetic data that we generate ourselves. So we don't have any personal IP addresses in that data, so we don't need elaborate data sharing agreements. So for the testbed, we need what I call a virtual anti-DDoS coalition of Concordia partners that have a non-production environment in which to deploy the clearinghouse. We need the clearinghouse components, and we need a way of generating DDoS data without the personally identifiable information, so some sort of traffic simulator. Also, to prevent more legal documents about liability, each member of the virtual anti-DDoS coalition can only request traffic to be sent to themselves through an online dashboard. And this will only be a few megabytes of DDoS traffic. So it's just enough to test the system and not to actually penetration test one of the Concordia partners. So with those components, we can pilot the entire clearinghouse system on the testbed. And the first step is for one member in this virtual anti-DDoS coalition to request some attack traffic through the dashboard. And the traffic simulator will then send it to that requesting partner. They will capture this data and analyze it using the dissector module, which will generate a fingerprint, which will be uploaded to the DDoS DB. And the other members in this virtual pilot can then download these fingerprints and use a converter to create mitigation rules from this fingerprint. And they can then install these on their firewall. And then the second part of this test is for that second member, so the other member in this virtual coalition, to request that same attack that was previously sent to the first member. And then hopefully we see that the attack is largely blocked by the generated mitigation rules. So that's what our test tries to accomplish. So test the entire system from the back, from a DDoS attack to the blocking of that same DDoS attack at another member. We've set up this testbed and ran a pilot of the system with 2 Concordia partners. And we created a demonstration video of that process. It's a short 5-minute video, so I can show that here. Let's see if the sound works as well. You should be able to hear the sound now.
Hi, my name is Thijs, and I work as a research engineer at SIDN Labs.
And I'm Remco. I work as team lead security at SURF.
In this video, we will introduce and demonstrate the testbed that we've developed for the DDoS Clearinghouse.
The DDoS Clearinghouse is a system that allows you to share fingerprints of DDoS attacks, and that way organizations can prepare for attacks before they actually hit them, and it's one of the cornerstones of the anti-DDoS coalition.
The Clearinghouse consists of 3 core components. When a member of an anti-DDoS coalition receives an attack, they can analyze the DDoS traffic using the dissector. The dissector summarizes the attack's characteristics into a fingerprint. The DDoS fingerprint contains information such as the source IP addresses, target ports, and communication protocols. The dissector shares the fingerprint with the rest of the coalition through the DDoS DB. This is a central database in which DDoS fingerprints are stored and shared with the coalition. Other members of the coalition can use a fingerprint to proactively combat the attack. We can use a fingerprint to generate traffic mitigation rules using the last core component of the DDoS Clearinghouse, which is the converter. With the mitigation rules in place, the same DDoS attack can be warded off by other members of the coalition.
Now, we're developing all this in a European project called Concordia, and we're going to test this with the Dutch anti-DDoS coalition.
Deploying the Clearinghouse requires organizations to change their production networks and have data sharing agreements in place with the rest of the coalition. The legal and technical developments are both essential to the DDoS Clearinghouse, but they happen at different speeds.
Because we don't want these tracks to slow each other down, we set up a testbed that closely resembles an operational setting. That way, we can test and demonstrate the DDoS Clearinghouse without actually having a data sharing agreement in place.
Our testbed consists of 3 elements. The first element is a virtual anti-DDoS coalition. To test a clearinghouse in practice, it has to be deployed in a coalition. Our coalition consists of SURF and SIDN Labs. The second is the traffic simulator. Using the traffic simulator, we can generate traces of DDoS attack traffic and send it to one of the partners in the virtual anti-DDoS coalition. The last element is the DDoS Clearinghouse components deployed throughout the virtual anti-DDoS coalition. Members of the virtual anti-DDoS coalition can request traffic to themselves via an online dashboard. And this traffic is not of the same caliber as a real DDoS attack, it's just enough to test the cycle of the DDoS Clearinghouse. And because this generated traffic does not contain personal IP addresses, we are free to share it without a data sharing agreement. We will now show you how we use our new testbed to pilot a DDoS Clearinghouse. First, I will request some traffic from the traffic generator to SIDN. On the traffic generator's dashboard, I can customize the packets that make up the attack. Here I make the traffic generator send traces of a UDP flood attack on port 8989 to SIDN. This graph shows all incoming traffic on the target server at SIDN. We can see the DDoS attack by the spike of traffic. I stop capturing the attack, and we see that we have gathered some traffic on port 8989. I can now feed this traffic capture file to the dissector module of the DDoS clearinghouse. Here we see a preview of the DDoS fingerprint generated by the dissector and see that it is successfully uploaded to the DDoS DB. On the web interface of DDoS DB, we can indeed see the fingerprint we just created. It is a UDP flood attack on port 8989, and the source IP addresses are those of the traffic generator.
I will now download the fingerprint from the DDoS DB itself and use this information to mitigate the DDoS attack that will now be targeted at serve. With the fingerprint and the converter combined, I can create mitigation rules that will help the firewall at serve to ward off this attack. I will now request the same attack that we just sent to SRDN Labs, and hopefully we can see that we don't capture any of the DDoS traffic because of the mitigation rules that we just created. The graph on the right shows all the incoming traffic, but we can see that the attack traffic is mitigated by the rules that we just created. We can use our testbed to test the DDoS clearinghouse with many types of DDoS attacks. This way we can also test new developments that we make without having to change anything in a production setting. This makes it a lot easier for us to continue the development of the DDoS clearinghouse.
In the future, we will pilot the DDoS clearinghouse in the Dutch Anti-DDoS Coalition. This testbed provides us with an opportunity to interactively test the clearinghouse, to show off its added value to prospective new partners, and to better prepare us for its deployment in production. If you'd like to know more about the clearinghouse or the testbed, visit knowmoreDDoS.org.
All right. That's one of the promo videos that we made. I hope it illustrated the use of the testbed well. So we can indeed test the entire clearinghouse system front to back on the testbed. And our outlook for the coming period is to pilot the clearinghouse in the actual anti-DDoS coalitions. We will summarize our lessons learned in a cookbook. We plan on proposing the fingerprints for standardization in the IETF. We will also implement better communication between the DDoS database and MISP, which is another threat intelligence platform. And finally, we will wrap up the Concordia project with a closing workshop at the end of summer. Thank you very much for listening. If there are any questions, I'd be happy to answer them.
Thank you very much. Great presentation.
Thank you.
So I don't know if there are any questions. Okay. Yeah, I see one.
I would like to ask if you know how much fingerprinting is sensitive to small variations in the attack patterns, like different port numbers, different variation, or different parameters that are registered in the fingerprinting.
Yeah, so this information, like the target or destination ports, are included in the fingerprint. The fingerprint is mostly used to share the information with other coalition members, and one of the things that you can do with it is use a converter to generate the mitigation rules. The converter currently is still a prototype, so it currently blocks the traffic from the target or from the source IP addresses to the target ports. So in this case, it does matter that the target ports are those that are targeted in the fingerprint as well. But with some imagination, you can create your own mitigation rules that are inspired by the fingerprint, and that way you can customize it however you like. Does that answer your question?
Yes, partially, because I think that the real challenge is to generate the rules from a
That is definitely a challenge.
Can account for different variations of the attack. So probably this is
Yeah.
the real challenge today. Okay,
It is one of the challenges and one of the things that we're still working on, how to create a good converter. Yeah, that's the main challenge now. But we still have a year left of development. So. Yep, thank you.
May I have another question here? It's Martin from Testnet.
Yeah.
So regarding the fingerprint, is there a possibility to link the fingerprint with the sample of the traffic? Is there a let's say way how to represent it? in the fingerprint.
You mean that you can tell which traffic capture belongs to a fingerprint?
Yes.
Well, there is the option to also upload the traffic capture to the DDoS DB alongside the fingerprint. Currently in the pilots, we're not doing this because that complicates things with the data sharing side of things. But in the anti-DDoS coalition, there are these data sharing agreements in place. And I believe that allows them to share the network capture as well alongside with the fingerprints.
Okay, thank you. Yeah, because actually at SAPPAN, I was working on something that you can call converter. So based on the sample of DDoS as well as on the sample of normal traffic, you can generate the precise mitigation rule.
That's very interesting.
But it actually requires the sample of the traffic. I'll send you a publication about it. It hasn't been published.
Thank you.
Sure. So please do not resend it.
No, I won't.
Thank you very much. Peace and
Thanks for the invitation.
So let's move on to the next talk. Is Francesco here?
Hi, Manos.
Okay.
Good afternoon.
Okay, so I was trying to find you. Okay, so the next speaker is Francesco Osimanti, Senior Project Manager at Trust IT, and he's here as the Standardisation 2023 Vice Coordinator to present us this interesting new project.
Yeah. So here I am. Good afternoon. I'm trying to familiarize back with the GoToMeeting. It's been a while since the last time I've used it. I hope you can see my screen. So thanks a lot, Manus, for having me here. I had the chance this morning to pop up. I couldn't follow the entire meeting. It was really engaging, and congratulations for this. And I saw also some old friends of Standardisation in the list of participants. I saw Leosha and Shakira. I don't know if they are still online. That was really nice to see. You know, Standardisation.eu. I don't know if you have already had the possibility to get some information about our project. My presentation, of course, won't be rich of technicalities as yours, because our project is not cybersecurity driven as yours. Standardisation is a coordination and support action, and it's also very transversal and cross-sectorial. It affects and it impacts all the ICT technological domains of the digital SIMARGL market. But it's very relevant for a cybersecurity expert. That is proven by our last 3 years, since we had dozens of funded experts coming from the cybersecurity field. So in this regard, I think it might be useful for you to know, to get an overall an overarching overview of of what Standardisation is. As I told you, we started 4 years ago with this is actually the follow-up of the project. Sorry, I'm trying to move in my slide, but I don't know what's happening. Okay, I just have to scroll the mouse. Standardisation 2023 is a follow-up of a previous project running from 2018 to 2020, and that managed to fund over 250 experts coming from different ICT technological fields, but especially from the cybersecurity ones. What is Standardisation made up for? Standardisation is born to support ICT specialists working in standards, not only in cybersecurity, but in a wide array of domains. Technically speaking, the domains included in the ICT rolling plan for standardization. There's an yearly release from the European Commission that lists down all the most important and innovative domains. Standardisation actually it's about giving money to the worthiest applicants to perform their work within the most important European and international standard developing organizations. This can be to perform a work on a standards, to draft the standards, to bring contribution to ongoing standard, to meet, to attend a regular meeting within technical committees or working groups, and even to attend events or run some roles within the SDOs, like chairing or co-chairing a specific group. How does this work? We have a series of open calls, 9 in this case in the current project. We have, by the way, in these very days, we are running the 6th open call that is going to have deadline next week, just for you to know. And we have a 3 million euro of budget available that is broken down, is staggered across these 9 open calls. And at the same time, we have a pool of external and fair independent evaluators that are supposed to judge and to evaluate the received proposal according to some crystal clear criterion that you can see listed here in the slides: the soundness of the proposal, the technical excellence, the expertise of the candidate, and of course the economics. The applications are iterative. This means that the applicants can apply for more than one application, and this is made to ensure continuity to the work carried out by every candidate. We have several cases of candidates that repeatedly won their proposal, and they managed to bring further their job, because the maximum lifetime of a proposal is 6 months, but there's no limit in reapplying for more funding for a maximum amount of 10,000 K. I wanted also to give you a more tangible grasp of what we did so far. These are it's a snapshot, it's an overview of what happened in the first 4 open calls. We are now finished to evaluate the 5th open call result, but I don't have yet the final results. You can see so far we managed to fund and to sustain financially 144 different persons that are heavily involved in standardization development for an entire amount of 1.2 million euro. And you can see that cybersecurity is by far one of actually the leading topics among them all. And this is something that it's a continuation of what happened with the previous project. So this can be, certainly better than me how to read the statistics. Probably it's because cybersecurity is a so wide topic that needs a lot of standardization. But some fact and figures I would like to report to you here is that the huge variety of the background of the candidates that apply for our open calls, coming from a large industry, SMEs, research and academia, SDOs, of course, taken for granted. And also, this is a win-win solution also for standard developing organization. You can see at the bottom of the slides, because they can benefit for free of this the solid expertise of our applicant. And that's why we have been not praised, but we have been, let's say, thanked by many of them for supply them with this free know-how and expertise in these past years. It's worth of mention this group of people that probably I'm pretty sure some of you, if not all of you, are quite familiar with some of them. It's our external advisory group, as we call it. It's the backbone of our project. This is a group of esteemed experts coming from different backgrounds, from the European Commission, from standard developing organization, from a network of a standardization organization. And we rely on this group of people to keep the project on track. They give us a guidance and tell us which is the road to follow whenever there is an emerging topic, an emerging trend. We rely on them to adjust the project accordingly. You can, if you want to know more concretely, let's say, what kind of achievement, what kind of finding, and how the applicants could truly benefit from the support of the project, you can take a look at the impact report. It's a fancy booklet that we routinely publish through our channels, and where we collect a survey that every funded applicant have to respond to. This is pretty useful because especially if you dig into the cybersecurity expert, you can have an understanding on what they are working on, and maybe if you are yourself involved in and of course otherwise you wouldn't be here, but in cybersecurity standards related activities, maybe you can make up your mind to apply for the open call and get some benefits out of the project. All of these materials and other stuff that I'm going to show you in a while are easily retraceable on our website, of course. What is changed in this follow-up edition of the StandICT project is that StandICT is the primary goal is still the same. But put it very simply, it's about giving money. It's about supporting people in carrying out and attain their achievements. But it's not just about this. We added another pillar that is the YOST, that stands for European Observatory for ICT Standardization. This is an interactive area within the StandICT website. It's a kind of an open forum with that includes a discussion forum where you can share your insights, your novelties, whatever you want in a specific ICT domain. You can join other experts there, and we added also a repository of standards. This is an ongoing effort. We are still working on that on a weekly basis, because what we want to achieve and what we want to set up by the end of the project. It's a quite comprehensive repository of standards to give a clear mapping of the most important ones in the most critical domains. And of course, cybersecurity is at the top of this. Sorry, I'm moving too fast. Technical working groups. What are the technical working groups? Within the YOS, we decided to create the selected groups of experts. These are actually private groups, but they are the cherry on the cake of the StandICT project. We managed to recruit and to make these experts come together, to work together in this private group, to provide a landscape and gap analysis report for each of the main ICT domains that we have been pointed to by our project officer. And of course, cybersecurity is included as well. As a final outcome of their activity, they are asked to produce this comprehensive landscape report, landscape gap analysis report. It's actually a booklet, a digital publication that we release once every couple of months. And so far we have already issued the artificial intelligence and the smart cities one. Trusted information is another topic that is going to be released in a matter of days. And the cybersecurity technical working group is also underway, and the publication, the correlated publication, will be issued in few weeks. You can see here a snapshot of the release of the publication we issued so far. And I mean, the report is these reports are very important and have been also quite popular with a lot of download from our website and from Zenodo, because they provide a very detailed, a thorough wrap-up of the standardization landscape in each of the correlated domain. Again, here you can easily find them online on our website, or simply scrolling down very quickly our social media. At the same time, the third pillar of the Standard-ICT is the Academy, the EOS Standards Academy. One of the objectives of Standard-ICT that is quite aligned with a commission goal to train the next generation of ICT standard specialists is the EOS Academy. The Academy is going to be an educational hub that I have to stress that this is still underway. You are not going to find today this in the website, but I wanted to, well, I mean, give you a preview of what we are going to do in the next part of the year. And we want to set up this repository of teaching material that is supposed to be very helpful to support, especially the newcomers in the field, to get a primary understanding of what standardization is, and to find relevant material to get to know it, to learn more. At the same time, this is not going to be just for beginners, but also for intermediate and advanced users. There is a group of people, a group of experts behind this EOS Academy, and well, even here, if you're going to stay in touch with us, you'll see how we'll this pick up in the coming weeks. Another gender balance is another aspect that we take into account very seriously, and that we worked on quite heavily in the last weeks, because we noticed that in the first open calls we witnessed an imbalance between the male and female counterpart. We have fantastic women ICT applicants in the project. Shakira, by the way, it's our testimony in here, because she's a funded expert as well. But we would like to increase the participation and engagement of women in the project. Something that we want to do in the coming months, but we start to do literally in the last weeks, because we decided to start a brand new series of event. We call it Women in ICT Standards webinar. Of course, this event has been very, very nice and engaging. Is past. It took place the past week, 10 days ago. But it's not going to be a one-off event, but just the first one of a long series. I don't know if you are already familiar with the events we usually carry out. We call them a walk and talk webinar. This is a branded and very successful series of events we carried out across 2021 to map. Each of them is dedicated to a specific category, specific technological field. We had, of course, the cybersecurity one as well. You can find all of them in our repository online. And we are going to. One of the reasons why I'm here today is also to liaise, to deal with to some of you, to find potential synergy for new joint event in the cybersecurity field in this year. And yeah, I think last reminder again, I'd like to share with you is that deadline for the current open call, 6th one, that is set on the next 14th of February. I think it's next Monday. I just go by heart. So you are definitely invited to share the news, but also to apply for yourself as well. Because I think if you work in standard, this is really worthy. the application process is quite seamless. It's relatively easy. Of course, it's not a matter of 5 minutes, but if you are engaged in standardization, it's definitely worth a shot. I hope I've been quite clear, because this is the end of my presentation. Manos, I'm here to take any questions, and I would also like to drop my email address in the chat if any of you would like to get in touch with me for really anything.
Thank you very much for your interesting presentation. So I don't know if there are any questions from the audience. Okay, I don't see any. From what I understood so far, what Standard-ICT is to support individuals, right?
Yes, yeah, I didn't say that. That's a good point. Yes.
So
it is possible. It's individual. You can apply on behalf of your organization, company, whatever. But but concretely speaking, the money goes to the bank account of the individual. But the contract can be framed also in conjunction with the organization, SDO, or company you work for.
Okay, but since there are a lot of projects here, is there a way that projects somehow could contribute to this work pro bono, because we are already receiving funding for working on standards? We just want to have some greater impact in the decision making and the standards process. So do you think there is a way or something in the future that could more actively involve projects to participate?
I think the easiest way that I see is to, for any potential interested project, is to send some representative to work within the correlated technical working group of cybersecurity. That is, by the way, I think it's one of the most crowded one. It's one of the most numerous ones with a lot of experts already. And I can put you in touch with the YOSTER director, Mr. Ray Walsh from the Dublin City University, and so he can include you and bring you on board of on the technical working group.
Thank you. I don't know if there are any other questions. Okay. So thank you very much, Francesco, for having you here. If you would like to stay a bit more for the next presentations. Okay, so the next one is going to be from SAPPAN project. Sorry, it's going to be from Matteo. The interface to cybersecurity and functions, an overview of I2 NSF and OpenC2 standard. So, okay.
Yes, let me share my screen. Can you see it? No. Okay, can you see my screen now?
Yes.
Okay, I'm going to give you a very quick understanding of what are the main interfaces in the field of cybersecurity in terms of interfaces to security functions. So basically, agents, security capabilities for monitoring, inspection, and enforcement. I will not cover, of course, standardization aspects related to information sharing and things and interoperability between softs and things like that. There are a number of motivations for this kind of interface, mainly the externalization of security services, which are even more delegated to third parties that therefore need some kind of interface to interact with agents deployed in local environment. There is also the growing complexity of digital applications and services, which are ever more designed as a system of systems. And so statically configured cybersecurity appliances are no more manageable for cybersecurity operators. And also, as I told this morning, there is an increasing number of dynamic and agile systems that need the same characteristics for cybersecurity processes. There is also an evolving shift in paradigm in computing paradigms from monolithic applications to cloud models like infrastructure as a service, platform as a service, serverless functions, and things like that. Most of all, there are currently large heterogeneity of interfaces and devices that make it difficult to create cybersecurity appliances because they need a lot of different interfaces to interact with different agents and services available today. There is also the common understanding that the perimeter defense is no more effective today. So basically, we cannot rely only on firewalls, IDS, VPN gateways, but we need more kind of security services, including also detection services already implemented by cloud providers. And okay, the scope will include of devices in the demilitarized zone, endpoint protection, monitoring and inspection, detection, and analytics. So there are a number of challenges for this kind of system, including mixed deployments that could be partially on premise and partially in cloud, the presence of external resources like IoT devices, the utilization of 5G slices, stores, digital processes, and as I said, the lack of a physical boundary for these kind of systems. And this kind of system are also going to be dynamic, so they include elastic services that usually scales according to the workload or to errors or failures, for example, by replicating the services, by increasing the number of replicas, by providing backup instances, and so on. There are a number of architectures that are increasingly make usage of service-oriented paradigm, web services, service meshes, and things like that. There is also the problem that many functions are today ephemeral. They are built with virtual machines and Kubernetes containers that once stopped doesn't maintain a persistent storage, at least doesn't maintain a persistent storage for the whole system in general. There are NFV and SDN systems that are virtual and of course have similar properties to cloud applications. And there is also a lack of visibility on modern paradigms, like in PaaS and serverless environments where you cannot deploy traditional agents. You have to find new mechanisms and new tools for getting the monitoring data. Of course, you can rely on the infrastructure provider, but sometimes what the infrastructure provider is not enough. In any case, you need to configure it in a proper way for your detection appliance. So, okay, other challenges include the availability of heterogeneous devices and interfaces. So we have the traditional cybersecurity standalone appliances, and on the other hand, we have cybersecurity services provided by cloud providers that are available through their web interfaces usually. There are different configuration methods available, files versus REST API. There are different ways to configure applications like signatures for the traffic or profiles for anomaly detection. There is the need for capability description because you need to know what kind of monitoring, enforcement, and inspection processes are available from each domain, from each agent. There is the problem, of course, of a common representation of event logging and data, which is necessary to process them with machines. And there is an ever more important need for automation and of response and mitigation strategies. I already talked about the emerging paradigms based on service-oriented architecture, which boost the creation of distributed environments based on microservices architecture. And finally, of course, there are a lot of problems with key management and the distribution of secrets between the different environments. So basically, there are two initiatives that I think it is worth knowing today. One is from the IETF, which is, of course, probably the most authoritative standardization bodies in the internet domain. And the other one is from OASIS, that probably is most related to in computer science. But in any case, they are very similar, but with big differences in the approach and what you provide you for your communication interfaces. The first one from the IETF is named Interface to Network Security Functions, and it is largely network biased framework because it was considered explicitly to manage network functions. Even if I think it could be quite easily applied to many other different environments. The focus of this framework is on data models, so the description of the interface capability and the configuration you can do. Also, as I will show in a while, there is a lot of effort about the definition of automation through the definition of specific policy. The other framework from OASIS is OpenC2, Open Command and Control Language. As the name implies, it is mostly a language for machine-to-machine communication for cyber defense components. It does not cover a lot of aspects like sensing, analytics, and reaction. It only focuses on control of remote security agents. Let's start with the I2NSF architecture. You see several components in this picture. I have to say that there are only a few RFC available for this framework, while most of the documents are still in draft. So basically, it is still evolving, and if you look at this framework, you will find some inconsistencies, errors between the documents, because probably they have still to be aligned and before going to the final version. But in any case, its basic layout is now quite clear. Basically, there are three main layers. The first one is the user, which defines the policies and how the system should behave. And he is only the consumer of the data collected from the framework. The second layer is represented by the security controller, which is a smart engine that translates high-level policies defined by the user, maybe in a human-friendly format, into more technical configurations for the third level, which are the network security functions, basically agents and similar network functions. So sorry, security function. On the side of this graph, there are other two components which are expected to make the system more autonomous. One is the developer management system, the block on the top of the right side, which is a system for registering network security functions into the security control. And the second one at the bottom is the analyzer. The analyzer is a component that collects data, events, and measurements from the network security functions and provide refined policies to the security controller for implementing a sort of closed control loop. I mentioned the fact that there are basically clear 3 layers. At the top layer, there is the user, and the main purpose for this framework is to let the user the possibility to define policies in a high-level language. So something which is more human-friendly than the technical configurations of the security appliances. And the purpose of the security controller, as I said, should be to translate these policies into concrete configuration rules. Since the time is very limited, I just provide a very, very quick overview of the full system and components, just to draw some conclusions at the end of the presentation. So the registration part is necessary to make the security controller aware of what kind of security functions are available in the system and what are their capabilities. On the other side, the security controller can also query the developer management system to know these interfaces, or these functions, or to look for additional functions that satisfy or fulfill some requirements. Because, for example, there is a user policy that requires some kind of action that is not included in the set of registered functions. So there is a possibility to query to look for additional network security functions. The definition of a network security function is in terms of its name, vendor, capabilities, where capabilities are mostly expressed in terms of capability to implement an event condition action pattern. So basically, as we'll see, this framework is not for configuring single appliances, single network security functions, but better to configure some local reaction policies. So when an event occurs, if a specific condition is satisfied, there is an action to be implemented. Events are largely related to system events or alarms collected for the environment where the network security function runs, while conditions are mostly monitoring aspects of the traffic flows. So basically, they include parsing of the network headers, events generated by the network security functions. Okay, yeah, there are some details about the encoding of event capabilities, event conditions, and actions. Okay, sorry, I forgot to mention that actions are mostly related to actions on packets or traffic flows. So basically, they include pass the packet, drop the packet, mirror the packet for further analysis, forward the packet, encrypt the packet, and things like that. There are then other interfaces in the system. The first one is the interface between the security controller and the network security functions. This interface is conceived to configure the local network security function. As I said before, the configuration is mostly in terms of ECA pattern, event condition action. So for each network security function, we can define how the function behaves in response to specific events under a given condition. The other interface is the interface between the user and the security controller. In this case, this interface is conceived for allowing the users to define policies in a user-friendly way. Like, for example, okay, I don't want that department to access YouTube in working hours and things like that. Then these high-level policies are translated into concrete configuration rules by the security controller. The design, the current design of this framework, however, allow the definition of high-level configuration rules in a way which is very similar to the ECA pattern that is applied in the other interface. So probably there is not all this automation in the translation, or let me say the translation operated by the security controller is not really so powerful. In this case, if you have a quick look at the form of high-level configuration, you see the usual event condition action pattern as in the other interface. Okay, the framework also defines a framework for translating high-level policies into low-level rules. This is based on parsing the high-level policies and using a data converter to convert some high-level descriptions into concrete data. For example, by referring to the example I made before, the department is translated into a set of IP addresses. YouTube videos are translated into an URL. Similarly, the analyzer has an interface to collect data measurement from NS functions. In this case, the information collected by the analyzer is used to derive new rules or to report problems to the security controller. There are two different data models for these two different tasks. I'm trying to be brief and skip to the OpenC2. OpenC2 is focused only on the execution of a course of action. It implements a client-server model where producer generates the command and consumers execute the command. It is based on quite flexible communication stack. The typical option is to use HTTPS and JSON for encoding the information. There are basically two data models currently in OpenC2. One is for generic language specification, which defines the generic commands available, and another one is a specific profile for stateless packet filtering. OpenC2 messages are encoded usually in JSON inside an HTTP message. They can represent a command on the way from the producer to the consumer, and the responses on the way back. Each command is made by an action which specifies the command to be done, a target which specifies the entity the action applies to, an actuator who is in charge to perform the action, and some arguments that specify additional configuration for the action. The language, the standard envisions the possibility to define specific profiles for specific actuators. The profile is expected to define the actions that are meaningful for that kind of actuator, the targets that are possible for that actuator, and the arguments that can be used for that actuator. The profile is a superset of the basic commands, targets, and arguments. And basically, it also defines, as you can see in this table, what command can be applied to what target. So basically, there are some combinations that are not illicit or so they cannot be executed by the consumer. And the purpose of the profile is to define this kind of information. I am already over time, so I come back quickly to the conclusion. Comparison between the two frameworks. IconSF would like to be a complete high ACD framework, but really it doesn't cover security information and event management system in the correct way, in my opinion. OpenC2 has a narrower scope because it is only focused on remote control, and in this respect, it is comparable to the NSF-facing interface of I2NSF, basically the bottom interface. In I2NSF, we have two interfaces, one user-machine interface and one machine-to-machine interface, while in OpenC2, we have just one kind of interface. I2NSF is based on a declarative paradigm, which are policies. OpenC2 is based on imperative paradigm, which is verbs plus objects. Network security functions take control because they run action. Instead, in OpenC2, producers keep control because it issues commands that are just executed by the consumers. Other considerations are that there is a possibility to dynamically add new capabilities, a new function in I2NSF through the registration interface. While this is not possible in OpenC2, we rely on static profiles that must be defined at the design time. The transport protocol for I2NSF is the RESTconf and the netconf, and this is already included in the network biased approach that I said before, while OpenC2 can use almost any kind of protocol, HTTP, CoAP, and AMPQ, and so on. And the same for encoding. XML is the only option for I2NSF, while OpenC2 is more flexible. It mandates the usage of JSON, but you can also use anything else. My personal opinion is that the primary domain for I2NSF is networking, and for OpenC2 is the IoT. Another important consideration for a possible adopter is that the community of I2NSF seems to be closed. There are several open source repositories, but mostly outdated. While the OpenC2 seems more open from the perspective of contributions, and also there is a single repository. Also in this case, the software I see is a bit outdated, but probably there has not been a lot of development in the last months. Okay, the last part of the presentation was just to say that in our specific case in Garden, we can map the scope of the framework that I just mentioned before. The problem is that, in my opinion, OpenC2 could be more useful for us, but it lacks some capabilities. For example, the possibility to discover dynamically the capability of the agent, to discover linked services, and so on. And so, okay, we used another kind of models, which is based on smart data models that are being developed by the TM Forum in collaboration with Fireware. But this is another story, and this is an ongoing work, and we still miss a concrete contribution to the data model. We already elaborated the data model we need in our project, and we are still ongoing to submit this smart data model to the Smart Data Models Forum. So I think that's all for now. Sorry for being late, and if you have any questions, I would be glad to answer.
Thank you very much for your interesting presentation. Let me check if there are any questions in the chat. Okay. So just a question from my side, since you had the chance to work with both these initiatives and standards, let's say, you said that I2NSF is more broad and it covers more areas, whereas the OpenC2 is, let's say, more closed and it has a more narrow scope. Do you think that has, what do you prefer? So if there is a broader scope, this makes the adoption a bit more difficult, or do you think that we need to go small and standardize small areas and processes and then try to combine this, or just try to do something general to include everything?
Well, in this case, I don't think that broader scope is necessary better, because, but this is not a general consideration. It is a consideration based on what the standard provides. Because in the case of the I2NSF architecture, basically it provides you event condition action rules to manage NSF. But I don't see in many cases the real possibility to configure a security agent or a security function, whatever you prefer. And then it defines a data model for each possible function. So if you want to have a new function, you need a new data model. OpenC2 is more flexible in this respect, because it doesn't define the data model for the security function. It just defines the interface to send commands. And the configuration can be simply something like load a configuration file. So basically, if the security function changes, you don't have to change its data model. You just have to know that it will change it, and you need a different version of the configuration file. I think this is more flexible, at least for the kind of application we have in Guard. And I think most of us have a similar kind of applications which cannot be configured by a couple of configuration parameters, but often need really verbose configuration files. So in that case, I don't think that it is worth defining a static and rigid data model for the full function.
Thank you very much. So if there are any other questions, we can move on to the next presentation from SAPPAN project concerning the standardization efforts with the Cacao Technical Committee. Hello, Martin, again.
Hello. So I'll make the presentation full screen. Yeah. Okay. Can you see it full screen or still small?
No, full screen.
Okay, super. So in this short presentation, I'm going to wrap up our SAPPAN standardization effort regarding the cybersecurity playbooks and how it's evolved from the last year when there was this first joint workshop organized by CyberSANE. So our motivation behind the standardization of playbook was that the incident handling is in a majority a repetitive work. A reaction to a large portion of incident is the same. In fact, I mean the reaction vary based on the incident, but similar incident happen again and again, and the reaction to similar incidents follow the same pattern. So if I imagine that similar incidents happen all over the world and all the time, it would be great if these, let's say, boring incidents were not handled individually and manually, but rather if they were handled, let's say, collaboratively or in the same way and automatically. So it would be great if there was a pool of knowledge how to react to these incidents, and then the pieces of such knowledge can be shared with some customization and deployed in the infrastructure and automatically executed locally in the organizations. Essentially, the representation of incident handling steps is the key enabler to sharing and using them. Otherwise, not only the interpretation of the shared information may vary, but even the machine processing of the non-structured information is quite complex and requires quite an effort. So at the time of writing the SAPPAN proposal, there was no standard to represent the response and recovery steps, aka playbooks. Therefore, SAPPAN proposed its representation and format, and it was just few months before the first joint workshop on dynamic countering of cyber attacks organized by CyberSANE. And fortunately, due to this workshop and the presentation given at the workshop by Vassilios Mavroidis, we became aware of OASIS Technical Committee on Collaborative Automated Course of Action Operations, in short, CACAO. So I would like to thank and highlight the importance of such workshops, and it definitely makes perfect sense to discuss through these workshops and also listen to these workshops to be aware of what is out there. So since our next goal was to enable sharing of the playbooks, we wanted to figure out if we are not late again. And therefore, we got in touch with CACAO Technical Committee and discussed our aim to share the playbooks. And by several discussions, we figure out that the CACAO is in fact a STIX-like object, though yet not integrated within the STIX standard. Therefore, it made sense to us to focus not on STIX, but rather on, let's say, the second most popular sharing platform, MISP, and enable sharing of the playbooks for the MISP community. Moreover, our effort was quite supported by Siemens in the technical committee, who already expected that such an object already exists, and they planned to use it in Concordia, actually. Therefore, we had several meetings with the technical committee and discussed various alternatives, how to best model the CACAO playbooks in MISP, and finally, we arrived at the decision that to take the straightforward approach and prepare the MISP playbook object with just the specific attributes only for the metadata, while the whole copy of the playbook is stored as an attachment attribute in the object itself. This brings several advantages. It allows to share other playbook formats, so we can represent any format in this case, and it does not require the transformation of the playbook when it is shared and exported outside of MISP. Also, we discussed the playbook object with MISP developers, and finally we made it available in the official MISP object repository so that we can start to test its interoperability with other partners in either Concordia or whoever wants. So to sum up my short presentation and this short story of standardization, it was an interesting journey from figuring out that we duplicated the standard. On the other hand, it was quite joyful to cooperate with the technical committee, and it was easier for us definitely to gather several expert viewpoints on the playbooks and how to best model it, how to best prepare the model. So this is end of my presentation.
Thank you. Vasilios couldn't be here today. He was interested in participating and seeing your presentation, also the presentation from Matteo, but I promised him that I will send him the recording. So I don't know if there are any questions. Okay, so let's move on to the final presentation for today. I see Argiro is here. So the next speaker is Argiro Hadjipoulou. She is a lead auditor and trainer, a standardization leader of Concordia project and AI for HealthSec, member of ISO, SAN, SENELEC, and more. And she's going to discuss about the standards in the horizon, let's say 2020, Horizon Europe now, and how we can address the standardization in EU-funded projects. So, Argiro? Hello. Okay.
Hi.
Hi.
Give me a second so I can share my presentation first. Can you see it?
Yes, yes.
Okay, great. So hello to everybody. Hi, Manos. Thank you very much for the invitation and for allowing me to participate and trying to convey a little bit of my passion regarding standardization and about the things that can be done within this these sorts of tasks as part of Horizon projects. To start off, let's start with why are we talking about standards? So recently, like 5 days ago, we had a very big announcement that the European standardization strategy has been published, and we are very excited in the world of standards that we now have a strategy as a European Union that underlines and provides specific actions to be undertaken in terms of standardization. Why? Because standards are important. Because standards allow for us to have interoperability of products and services, help us reduce costs, improve safety, and foster innovation. Standards may not be as visible to everyday life as we would like to, but they're always they're like an underlying layer. So the reasons why some things work and some things work effectively is because of standards. And this importance has been underlined also in the European standardization strategy. And the ways to valorize the outputs of projects through standardization has also been put into more focus. A lot of standards exist from a lot of organizations that are providing standards, standardization development organization, SDOs. These organizations, like for example, ISO, or you may know IEEE, or other that they are related to open standards and the community. All of them have a specific contribution to society. You can find a lot more information from different standpoints and different perspectives within these standardization organizations. But all of them converge to one great conclusion, that standards help. That standards help us have more safe, more secure, more compatible, more approachable, more innovative products. They allow us to be able to talk for two products, for example, to talk between them, although they are made from different manufacturers. They allow us to buy products from different countries that are produced from different countries, having the same safety precautions embedded into them. And you can see how standards, even that are more management, more that are related to health and safety at the work in the work environment, can contribute to our everyday life. There are a lot of standards that are used, and not a lot of people know them. And I'm just putting this image up just to show you that. And I know you don't see the details, of course. It's a really long, big list. But I wanted to show you the extent of standards that are only issued by ISO, that is just one standardization organization, and are used in the oil and gas industry. So every little line is another standard, and it's used in order to to provide better service from the oil and gas industry. We also, in the area of ICT, have a lot of standards. And recently, there's a European Observatory for ICT standardization that has been created and now is powered by Standardisation, a project that you already showed during our previous presentation. In this observatory, in this portal, you can see standards that are related to ICT from the general standpoint to the very specific one that is related to specifics regarding security, regarding networking, regarding cloud computing, and it can go very, very specific. At this point, we have more than 1,000 available standards that are related to the ICT. So that there are a lot of standards, but there are a lot of standards also missing. We need to be able to provide as many standards as possible in order to create a common background. And this is the idea how why projects and other like Horizon Europe are supporting the valorization of research and innovation results through standardization. So what is actually written is that projects should provide strategies. For example, I took this from one call. Projects should provide strategies for transfer of the developed technologies to other industrial application scenarios, as well as contribution to standardization. Because in this way, we can leave a positive footprint. We can give something to the next person that will take it from there and also evolve it. And this will be a more of a value-added service that we can provide as a project. So all that, in theory, I think, sounds good and sounds very generic and very theoretical. And what we actually have to do within this project is think about how to do this. So there was this work group that was done hosted by DG Digital, and they were trying to do this pre-survey regarding a code of practice for standardization within European projects, European funded projects. And there were a lot of questions like that, like I want to provide into the standardization community, I want to be part of a standard, I want my results of my project to become part of a standard, but there is no clear way of how to do that. So one of the first opinions that was provided is that it's easy, you create a standard. Like everybody who's involved in any project regarding standardization knows that it's never easy to create a standard. There are various processes from each organization and different steps that have to be followed in order for a standard to be created. Even from smaller and less formal, let's say, standardization organizations, we have a lot of steps that have to be implemented. The steps, and I'm just giving you examples of two. So we have the two next slides from the Open Group, for example, and from ISO. All of these steps are based on the same, let's say, underlying principles. The steps start always with an idea for a standard, and then there is an acknowledgement that this is a good idea, that it is worth the effort to create a standard, that it would provide a positive value to everybody and the world in general, or a specific sector of the industry. And then afterwards starts the really difficult and interesting part, where opinions and proposals are gathered regarding what is going to be part of this standard. So we have this draft development process that it can extend to pretty serious amount of time, depending on how big the organization that is developing the standard is and how many parties are involved. Usually, to migrate from one step to the other, we have different voting processes, and it may take considerable amount of time. It could be just straightforward, so one after the other, right, like a serial process. But at any given point of time, there could be some setbacks. So there could be opinions from the participating participants that something is not going right with the development process of the standard, and it could go back for a couple of steps. So creating a standard is not easy. And I'm not saying this to discourage you. I'm saying that this should be taken into consideration, the time effect and how difficult the steps are, and how much effort you have to give to this devote on these steps has to be taken into consideration when you have in mind of creating a standard. And it should start very, very early. So that's another problem with European projects, right? We have a proposal when we start in the beginning, but that doesn't mean that from the beginning, from the first day when we sign the agreement, we know exactly what we're going to produce during the project duration. So then maybe it takes us 1 year to have some concrete information, something as an output, and then we can start creating a standard. But again, there may not be enough time, because depending on the organization, a standard developing process may take up to 4 years. So if we've already had 1 year to have something, to have provided something that could contribute to a standard, and then we start doing these connections with the different standardization organizations in order to provide this input and have the standard, then we're probably already too late. So that was definitely one of the issues that we discussed for the code of practice. And they made the suggestion that such a proposal should already be there, and if possible, within the project team, a standardization body should already be there, either as a connected partner or as a partner or something else, so that then there would be an easier way to gain access and to fast track as possible the different processes. A standard is not a person's opinion, so one person's opinion, but it's rather a result of consensus. A lot of people have to agree that what we are providing with the standard has a great value, and it represents like a baseline of information. So that also needs to be considered, that it's not just the opinion of one project, that we then, in order to have a very valuable standard, we need to have consensus. So we need to involve a lot of different parties, and if possible, different projects that would agree that this is a good idea, that these are good practices that should be represented in the standard. So all of these things need to be considered. And although when we think of standardization, maybe the first thing we think about is, yes, let's create a standard, we can do this. We can create a text like 20 pages long, that's no problem. It's not the first thing that we should consider when we talk about standardization within European funded projects. With the only exception to that, if the project by itself is all about one standard. For example, if the content and the aim of the project from start to end is related to a standard. In that case, of course, it differs. So another thing that we can consider is providing input. So we take the work that we do within the European project, and then we provide that to the standard developing organization, and they can use that feedback in order to improve their standard. So we can provide feedback, input, and comments. For example, there are many organizations that are open to getting feedback from members and from people that are outside the membership. In this case, we should definitely consider some things like, how do we join an organization that is providing a standard and is open to contributions, because there are always different requirements regarding the membership. For example, I have put in this slide here, one for OASIS Open and one for ISO, where you can see that in one case, there are some types of memberships where people can participate and be contributors to the technical committees and the relevant standards, either through their companies or as a person, as an individual member. And there are specific fees and specific ways that this can be done. But on the other hand, there are other organizations, like for example ISO, that although it says that it is open to getting comments, you can only participate through your national standardization organization. So if you want to, you have to first be appointed by your national organization for standardization, and then you will be able to provide comments and inputs to the standard, to a standard. In that case, although it is easier than creating a standard by itself, we need again to think some things over, to think carefully about some things and how they can fit into our project's timeline. So when there is an existing standardization effort, there is a specific timeline for that effort. So they have specific deadlines and they have a specific horizon in which they plan to provide the standard. This has to be, you have to be careful because it may exceed your project, it may not coincide 100%, and that is actually what happens in most cases. So it is pretty lucky if someone has the ability to provide contribution based on this project they are undertaking to a standardization process that is ongoing. Of course, again, we have to consider some things, and like time and consensus as before. And another thing is that whoever is participating, depending on the type of membership and the type of the standardization organization's procedures, they may be participating as a person. So this is also important because they would be representing their own opinion, and it is really difficult then afterwards to go and have measurable KPIs and report on the valorization of the project and the standardization activities when you are doing something as an individual and there is no control over it from a project perspective point of view. Of course, there are other also possibilities. That is that the project as a project can become a liaison. That means that there is a connection established between a project and a specific technical committee that is providing a standard. In that case, that is on the basis of the project itself, but we should in every case consider that there are specific prerequisites in order to create a liaison. There is a specific amount of time that is needed to be allocated in the liaison activities, because there is a reporting also, there is a review, there are specific activities that need to be undertaken. So it's not just a liaison, it's not a one-way street, but actually is that the project also is participating by reviewing specific outcomes and specific standards and specific inputs and comments from others, and provides a report. And of course, we need to consider that a liaison cannot be any organization. There are specific eligibility criteria that are imposed from its organization that is governing the process. Apart from liaison, we have also the ability to make recommendations like white papers and presentations towards standardization organizations, so that we show them where we are at. And I know it doesn't cite as a lot of things that to have a lot of impact actually, but it definitely helps. It helps because, you know, standardization is based on people. So people are participating in the different technical committees and they are providing their opinions and their knowledge. But if that knowledge is faulty, is not up to date, then they cannot provide the best possible results. So it's really important that we get what we do, we phrase it and we provide it as recommendations that we have validated and now that we are confident and maybe in the form of a white paper or a presentation, so they could be aware of this and then they could see if they could incorporate it in the standard. So I know that you have seen up till now also from others during the previous presentations other ways that standardization can work within the projects, and I'm sure you have a lot of more ideas. And the idea and what I wanted to do during this presentation is to show you that standardization is not just about creating a standard. It's about finding a place where you can express best practices, but first you need to create the best practices and then trying to get that information out in the open in order to be used by standardization organizations. Of course, the closest relationship, if you have a close relationship to standardization organization, you can participate in a technical committee, either as a liaison or as a member or as a member of observant member even of a technical committee. Of course, that could be best and contribute directly, but it's not always easy. And as I said, we did this workshop regarding the code of practice for standardization, and one of the things that actually we discussed is that although standardization organizations may not see it that way, there is a difficulty in reaching them. So there is a difficulty to find the right person to contact, to get them on board, to have a meeting, to present your work, to become a liaison. There is a difficulty in the process, a difficulty in the communication. So we have some barriers to overcome when it comes to standardization, but it's definitely something we should take into consideration. It's definitely something that we should do in relation to the results and the outcomes of our projects. Hopefully by next year we will have a code of practice for standardization, and it would give us a lot of more guiding principles of how to develop and implement standardization within the project. But until then, we can see we can still continue to the best of our knowledge and put our best efforts in order to have standardization as part of our project. So I would like to thank you very much, and I'm open to questions.
Thank you, Iro. It was really interesting. Are there any questions? Okay, from my side, one, let's say, question that always pops into my mind is, are there any standards for the standardization bodies that they follow in order to create standards? And
yes, that's a very nice question. You know, it would be a paradox, you know, not to have a standard for the standards from a standardization organization. Yes, there are a lot of standards. It's a very typical work. I understand, you know, what they say about people that are providing standards. I know we seem a little dull to everybody else. It's hard. A lot of people ask me why you are so enthusiastic about standards. I do believe in the value of standards, but don't get me wrong, it's very it's a very difficult process, and it's very detailed process. So we go through every word again and again and again before we release it, and still we release it and we find problems. And there are a lot of standards behind that tell us how to go, for example, from one phase to the other, like I showed you before, how to go from one stage to the other, who can participate, when do we do the review, how to write it, and how to write it correctly, how to write it with take into consideration gender issues, everything. It has a lot of standards.
Thank you. Another question is there an enforcer of standards? So how are standards enforced? So yeah, you have created this great standard, but if no one's adopted or enforce it, then what happens?
Yeah, actually, the work from a standardization point of view actually stops at the point where you give out the standard. So for the SDOs, the standardization organizations, they just stop there. What happens is that we get feedback from the market regarding the review and the optimization of the standard, but the standardization organizations are not involved in anything that has to do with the enforcement. There are actually two ways that you can see that that standards are enforced. One of them is they become some kind of an obligation, either a legal or a regulatory obligation, or they are mandated by market. For example, we have there's a GDPR, you know, the General Data Protection Regulation, and it says that people could use standards and get certified according to them under specific conditions if they want to prove compliance to the GDPR. So they could, when these standards will be created, you could follow the standards and then you could be audited and certified, and in this way it is made like a mandatory thing since it's mentioned in a regulation, and then it is also checked that it is correctly being implemented by an organization by the different certification bodies. Another way that is not related to certification is if it's made necessary by the market itself. For example, I know you know this, that there is a standard behind PDF, you know, the type of document, the PDF. There is a standard behind JPEG. So in order for every application to be able to process PDF or JPEGs, they need to use the standard. They need to do this specific encoding. So if they want to, for their application, for example, to open and create PDFs, they have to follow the standard. So it's mandated by the type of operation of the organization. So you have all these two. But the checking of the implementation, that's something different.
Yeah, thank you very much. I was more concerned about, you know, cybersecurity and in applications and whether they follow some standards, just to know that, let's say a government is creating a new application and following these standards, it would be certain for a number of vulnerabilities, let's say.
The only thing that I can say, just like to focus it on standardization, it would be in cybersecurity, it would be the CSA, right? So the CSA, the EU CSA, the Cybersecurity Act, it says that products or services or processes could be certified regarding the security. So that would be a way that they can, that the level of security could be verified actually in that case.
Okay, thank you very much. I don't know if we have any other questions. Okay, I don't see anything in the chat. So
hello.
Hello.
Ask a question.
Yeah, of course.
Hi. So, where there is a very well-known, let's say, drawing from XKCD, where it says, there is no good standard for X, I'll make the new standard, and that's going to be the standard. And now we have X+1 standards. How do you know that you have struck gold, that you know that the standard is good enough to be adopted versus it's just another standard and it's just one more?
That's a very good question. The only thing that we can do is through consensus. This is why consensus is used so much within standardization organizations, and this is why the more complicated the process to create a standard and the more people that are involved, the better the standard is. Although it makes it a lot more difficult to create and it takes more time. So if I sit by myself as an individual, or as a company, and I think of something, it's just my opinion. But if I validate it through others, if I run it through others, and then if I provide it to even more and in more extended ecosystem, and I get feedback and I get other information, then I improve it, and I get this consensus from a lot of people saying this is a good idea. So this is the only way that we can increase, that we can know that a standard has some value to the public and to the relevant organizations. And this is why we want to have as many people participating as possible and have the most current information as possible, so that we don't create standards that are obsolete and they actually provide wrong information or not very valuable information. But consensus is the only way, and as many as interested parties from different perspectives can be involved as possible, that would be the greatest.
Thank you very much. Are there any other questions? So I think not. So many thanks to all participants, of course to Fiverr that supported the whole workshop and provided the link and all for the event, everything for today. All the speakers and the projects participating here. So thank you very much.